ये डस्टर स्टार्ट करें। So let's start with chemical kinetics. Before starting the principle of chemical kinetics, if we want to classify the chemical reaction, classification of chemical reactions, so there are different way to classify a particular chemical reaction. For example, some reaction are redox, some reaction are acid base, some reaction are decomposition. But on the basis of rate of reactions, reactions are classified into three different ways. One is slow, which required at least 1 month of time to complete. Other is very fast, such as acid and base. And last is moderate rate of reaction. So the law of chemical kinetics is valid only for the reactions which are moderate speed. Let us consider reaction A plus B give rise to product, or X give rise to Y. Time t equals to 0. Time t equals to 0 represents the time when the reaction is not start. At time t equals to 0, assuming that we have taken 100 moles of X. At time t equal to 0, moles of X is 100. At this time, product is 0. After 10 minutes, 100 mole decrease to 80. That means how many moles reacted? 20 at 10 minutes. So we can say rate is 2 mole per minute. 20 moles of X reacted in 10 minutes. That means rate is 2 mole per minute. Now, if the same reaction X give rise to Y, and at time t equal to 0, I have taken 10 moles. After 10 minutes, it decreased to, let's say, 8 moles. In this case, if I have to calculate the rate, it will become 0.2 mole per minute. So this is case 1, case 2. In both the reaction, the reactant is X. In both the reaction, the product is Y. But in the first case, rate is 2 mole per minute. In the second case, the rate is 0.2. So why in the first case rate is higher? Because we have taken concentration at the higher end. So can I say rate of any reaction is directly proportional to concentration of reactant if the reactant is X. So rate of any reaction is directly proportional to X, or concentration of the reactant. So if you increase the concentration of reactant, rate increases. That means rate can be written as K multiplied by X. K is rate constant. When the time t is 0, the concentration is 100. When time t equals to 10, the concentration is 80. And rate is directly proportional to concentration of X. After 1 minute, time t equals to 1, can I say the rate decrease from 100 because the rate is 2 mole per second. So after time t equals to 1, it is 98. Is it clear? After time t equals to 2, it is 96. Can I write this? After 3, again decrease to 2. After 10 minutes to 80. Is this line is correct or any error is there? No. If I write at time t equal to 0, 100 mole decreased to 98, that means 2 moles reacted. When the concentration is 98, again 2 mole reacted. When the concentration is 96, again 2 mole reacted. That means decrease in concentration has no effect in the rate of reaction. But as we wrote, rate is directly proportional to x. So when the concentration is 100, the rate must be higher. When the concentration is 98, the rate must be lower than the first second. So this is not the correct representation. But we can able to say that if x give rise to y and I have taken time t equal to 0, it is 100. I can say after 1 minute, it decreased to 90. After 2 minutes, it decreased to 85. After 3 minutes, it decreased to 84. Like this, after time t equal to 10, it decreased to 80. In the first minute, the rate is 10 mole per minute. In the second, the rate is 5. Again, it is 1. So rate continuously decreasing. So we can say rate of a reaction is not constant value. It depends upon the concentration. As the reaction moves, the rate of reaction decreases. In the initial first second, the rate is very high. That means we can say rate of reaction actually of two types. One is the average rate represented by minus dx upon dt. Second is instantaneous rate represented by dx by dt. Is it clear? Now, average rate, when you are talking about the average rate, you are taking longer duration of time like 0 to 10. Therefore, the rate is 2 mole per second. But when you are writing dx by dt, you are taking nanoseconds. This is what we call the instantaneous rate, and this is what we call average rate. In chemistry, we deal with instantaneous rate rather than average rate. Clear? So, average rate, how you define average rate? Average rate is the time when the time is at the larger end, like 0 to 10. How you define instantaneous rate? Instantaneous rate is when the time is nanoseconds. We will deal with the instantaneous rate. Why this negative sign for the rate of reactant? Because the product is always less, because the final concentration is always less than initial. And when we are going to calculate the rate of reaction, it is always final minus initial. And we know that final concentration is always less. Suppose in this case, the final is 80 and initial is 100. But the rate is always in the positive mode. So we put a negative signs so that the rate will be positive. But if you represent the rate of formation of product, this negative sign will not appear because the final concentration of product is always greater than the initial concentration. Is it clear? So I can say for any chemical reaction, rate are of two types. One is average and second is instantaneous rate. One is average, second is instantaneous rate. Now let us consider a reaction A give rise to B. I am talking about instantaneous rate. Can I say minus dA by dt? Minus dA by dt. This is the instantaneous rate of disappearance of A. And dB by dt. This is instantaneous rate of appearance of B. In this case, if I say 1 mole of A reacted, that means 1 mole of B formed. That means instantaneous rate of disappearance is always equals to rate of appearance of B. Rate of disappearance of A in this case is equals to rate of appearance of B. Now, if the same reaction is represented like that, 2A give rise to B. In this case, if I say 10 moles of A reacted, that means moles of B form is 5. 10 moles is the rate of disappearance of A. 5 is rate of appearance of B. Can we write minus dA by dt equal to dB by dt in this case? No, because the rate of disappearance of A is 10 and rate of appearance of B is 5. That means if I divide 2 with the rate of disappearance of A, both the rate are equal. So when the coefficient is anything except 1, we can able to say minus 1 by 2 dA upon dt can be written as dB by dt. Why 1 by 2? The coefficient is 2. Now the rate of disappearance of A is 10. 10 divided by 2 is 5 and rate of appearance of B is 5. Both are equal. Is it clear? So if a balanced chemical reaction is 3A plus 4B give rise to 6C plus 8D, in this case, the rate law can be written as minus 1 by 3 dA by dt equals to minus 1 by 4 dB by dt equals to 1 by 6 dC by dt equals to 1 by 8 dd by dt. Is it clear? So I have divided all the coefficient with the rate so that all rates are equal. So in this case, we can able to say minus 1 by 3 dA by dt can be written as minus 1 by 4 dB by dt equal to 1 by 6 dC by dt. Clear? So in objective type of question, they used to write a reaction and there are 4 options. Which of the following is correct and the rate law is represented. Is it clear? So if I say 4A plus 5B give rise to 6C. 4A plus 5B give rise to 6C and rate of appearance of C. Rate of appearance of C is 5 mole per second. 5 mole per second is the rate of appearance of C. You have to calculate what will be the rate of disappearance of A and what will be the rate of disappearance of B. Find dA by dt and dB by dt. If rate of appearance of C is 4 mole per second. You can say 1 by 4 dA by dt can be written as minus 1 by 5 dB by dt equals to 1 by 6 dC by dt. Now, we know that dC by dt can be written as 5 mole per second. That means, can I say minus 1 by B dB by dt equal to 1 by 6 into 5? So dB by dt can be written as 5 by 6 into 5. Similarly, dA by dt can be written as 4 by 6 into 5. Clear? So with the rate representation, in general, they used to ask a chemical reaction. Rate of appearance of C is this much. How to calculate rate of appearance, disappearance of A and rate of disappearance of B. Now let us calculate what is the value of rate constant K. In a reaction A give rise to B, we write rate is equals to K multiplied by concentration of A. Clear? Can we say this rate is not a constant value, it mainly depends upon the concentration of A. If we increase the concentration of A, rate increases. Now, how you define rate constant K? We know that for different concentration of A, rate will differ. Higher the concentration of A, higher will be the rate. Can I say when the concentration of A is 1, when the concentration of A is 1, K equals to rate. That means when the concentration of A taken as 1 mole or 1 molarity, the rate is known as rate constant K. So how you define rate constant K? Rate constant K is the rate of reaction when the reactant concentration taken as 1. So we can say rate constant K for any reaction is constant value because it represents the concentration of a reactant to 1 mole per liter. Clear? So if I say A give rise to product, in another reaction A give rise to product. In this case, first I have taken 10 moles of A in 1 liter of container. In second, I have taken 100 moles in 1 liter of container. In case 1 and case 2, which case have higher value of rate constant? Which case have higher value of rate, first of all? Second, and the value of rate constant K is higher in same. Because in the second case, we have taken 100 moles, the rate will be higher. But when you talk about the rate constant K, you will take concentration of A is 1, concentration of A is 1. When the concentration is same, rate will be same. Therefore, rate constant K is not depend upon concentration. Rate constant K is not depend upon concentration. If you increase the concentration, rate increases, but rate constant K is defined for 1 mole. Clear? Again, if I ask you, A give rise to product and B give rise to C. These are the two different reactions. This is first, this is second, this is 10 moles, 100 mole. Between 1 and 2, which rate is higher? Second, and which rate constant K will be higher? K. First. In this case, we cannot able to predict which rate will be higher or the value of K will be higher. Why? We don't know the reactivity of A. It might possible A is more reactive than B. 10 moles of A achieved the same rate as B achieved by 200 moles. So it might possible A is more reactive. So rate may be higher in A. So we cannot predict the rate as well as K in this case. The comparison of rate and rate constant K can be done when the reactant and product are same. When the reactant and product are same, we can say higher the concentration of A, higher will be the rate, and rate constant K will be same for both the cases. Clear? But when you change the reactant, we cannot predict which reactant is more reactive, which is higher rate, and what is the value of rate constant K. Clear? So can I say in a reaction A give rise to product minus dA by dt. What is minus dA by dt? Minus dA by dt. Rate of disappearance of A. Can I say rate of disappearance of A is mainly depend upon the concentration of A? Is mainly depend upon the concentration of A. So minus dA by dt is directly proportional to concentration of A, and minus dA by dt can be written as rate constant K into A. This is one relation in which we have represented rate of disappearance of A with respect to rate constant K and the concentration of A. Now, if I say dP by dt, dP by dt, this is the rate of appearance of product. Can I say rate of appearance of product in this case is equals to rate of disappearance of A? We know that rate of disappearance of A can be written as K1A. So dP by dt is also K into multiplied by A. So you can say rate of disappearance of P is equals to K multiplied by A. Now, why? Because rate of formation of product is also depend upon the reactant concentration. If you increase the concentration of A, rate of formation of product increases. Clear? Let us consider a reaction A plus B give rise to product P. A plus B give rise to product P. Now, I have taken 10 moles of A, 10 moles of B, and at this time t equals to 0. At time t equals to 0, we have taken A 10 moles, B 10 moles, and we have calculated the value of rate of formation of product. Now we are talking about what is the effect in rate of formation of product if we change the concentration of reactant. When we have taken 10 moles of A, 10 moles of B, assuming that the rate of formation of product is 2 mole per minute. 2 mole per minute. This is experimental data. When the concentration of A and B are 10-10, the rate of formation of product is 2 mole per minute. This is experimental data. Now, let us change the concentration of both A and B. I have taken concentration of A, increase to 20, B will remain constant, 10. That means when we double the concentration of A from 10 to 20, keeping constant the value of A 10 to 10, let us consider or see the rate of formation of product. So there are three options. It might possible the rate of formation of product increase to 2 times. It might possible the rate of formation of product decreases. It might possible the rate of formation of product remain constant. So the effect of rate of formation of product by changing the concentration of reactant A is known as order of reaction. For example, if I increase the concentration from 10 to 20 and the rate of formation of product also increases to 4, then you will say, if I double the concentration of A, rate of formation of product also increase to 2 times. In such cases, the order with respect to A is 1. The order with respect to A is 1. But if I increase the concentration from 10 to 20 and the rate of formation of product from 2 to 2, in such cases you will say, if I increase the concentration of A, rate of formation of product remain constant. Rate of formation of product remain constant. In this case, the order of A is 0. Why 0? Because change in the concentration of A has no effect in the rate of formation of product. It might possible that when we increase the concentration of A from 10 to 20, the rate of formation of product decreases to 1. In this case, the order is negative. So I can say the order of any reactant is an individual property of an reactant A and B. Presently, we are talking about the reactant A. If the concentration, change in concentration of reactant A changes the rate of formation of product to higher value, the order of A is positive. If it will changing the concentration of A, rate of formation of product remain constant, order with respect to A is 0. If change the concentration of A, product decreases, order with respect to A is negative. So order may be negative, order may be positive, order may be 0, order may be fractional also. Order may be fractional also. It might possible if you change the concentration of A from 10 to 20 and the rate of formation of product is from 2 to 2.5. In this case, the order of reaction will be fractional. So order actually represents the exact change occur with the rate of formation of product with respect to change in concentration of reactant. To calculate the value of order, we are saying that rate can be written as K into concentration of A to the power X, concentration of B to the power Y. These X and Y are the respective order of A and B, and this is entirely experimental data. This is entirely experimental data. To calculate the value of order of a particular reaction, we generally use 3 different parameters. 1, reaction mechanism. 2, experimental data with respect to concentration and rate of formation of product. 3, graphical method. Correct? So how to predict the order of a reaction in a chemical reaction in which the mechanism of the reaction is given. Okay. So let us consider a reaction. Now I am talking about how to calculate order of reaction when the mechanism of a reaction is given. So let us consider a reaction. Let us consider Cbse, a well-known reaction. Formaldehyde in presence of NaOH react to form formic acid and methanol. This is an example of a Cbse. Cbse is a disproportionate reaction. Cbse is a disproportionate reaction because the oxidation state of carbon in this case is 0. The oxidation state of carbon in this case is +2, and in this case is -2. 0 to +2, 0 to -2. Same oxygen accepts the electron, same oxygen donates the electron. So this is a disproportionate reaction. So if I write down the mechanism of this Cbse reaction, you can able to find out the order of reaction. So I am writing the mechanism. In the first step, step 1, formaldehyde react with base OH minus. Formaldehyde react with base OH minus as a nucleophile, and it form this molecule. In the second case, O minus attack in the second molecule of formaldehyde, oxygen plus R effect, H minus, and it is converted to COOH, HCHH, O minus. In the third step, acid base reaction occurs. So there are 3 steps mechanism of Cbse, but this mechanism is valid only when the concentration of NaOH in the normal condition. If you take the higher concentration of NaOH, second step changes, and OH minus eliminate this hydrogen. One more step. So higher concentration of NaOH, there are 4 steps. But in the normal concentration of NaOH, this is a 3 step. Now in this case, the H minus release is in the second step, and this is what we call rate determining step. Rate determining step, also known as slowest step. Now, in numerical, what they ask, they have written a particular chemical reaction, and this mechanism is mentioned in the question. From this mechanism, you have to calculate the rate law or order of this particular reaction. Rule number 1, you cannot able to write rate with respect to any intermediate. In the final rate law, you cannot write any molecule or intermediate which are not present in a balanced chemical reaction. So rate is always defined in terms of formaldehyde, NaOH, formic acid or methanol. But rate cannot be written in the name of formic acid's ion or in this form or in this form. Clear? So always start with the rate determining step. So rate determining step is the second one. So you will write rate can be written as K2. Why I am writing K2, the rate constant of this? K2 multiplied by HO minus HOH and formaldehyde. Is it clear? Is it clear? Now, in this rate law, there is a molecule HCO minus HOH which is not present in the main reaction. So we have to substitute this. How to substitute this? Can I say in the first reaction, the Kc1 equilibrium constant for this reaction is HCO minus HOH upon formaldehyde into OH minus. Can I write this one? So HCO minus HOH can be written as Kc1 into formaldehyde into OH minus. Is it clear? So this intermediate from the final rate law can be substituted by Kc1 HCHO OH minus into HCHO. Now see, all the three molecules are present in my parent reaction also. Therefore, final rate can be written as K formaldehyde square multiplied by OH to the power 1. So we can say normal Cannizzaro reaction when the concentration of NaOH in the normal condition, the order is 2 plus 1, 3. So Cannizzaro is third order reaction mechanism. So how we have calculated the order of reaction in this method? Through reaction mechanism. Through reaction mechanism. Is it clear? So as I have told you that this Cannizzaro reaction, the mechanism is when the concentration of NaOH is in the normal at approximately pH 10. But I'm changing the reaction mechanism and you have to calculate what will be the order of reaction by this reaction. Clear? So when we take higher concentration of NaOH, when we take higher concentration of NaOH, the OH minus accept this hydrogen. OH minus accept this hydrogen. In this case, O minus, both O minus exhibit plus I effect. Due to this plus I effect, the H minus release will be in the faster mode. So the mechanism is like this. So in this case, third step is the rate determining. So find out the order of reaction. Third step is the rate determining step. So you have to find out the net order of this particular reaction. If third step is the rate determining, you have to calculate or your calculation start from the third step. So you can say you will write rate equal to K3, this ion multiplied by formaldehyde, but this ion have to substitute it from equation 2. So you can say rate equal to K3 into K2 now again this ion have to substitute it from K1. So if I remove all the rate constant to capital K, I can say this is formaldehyde, the order is 2, OH minus, the order is 2. So this is the fourth order reaction mechanism. This is fourth order reaction mechanism at higher concentration of NaOH. So if you understood the rate mechanism and the rate determining step, you can able to calculate the order of any reaction. This is the first way to calculate order of reaction. The second way to calculate the order of reaction is the data which is given in the question. For example, A plus B give rise to C. And the data given is concentration of A is 10, concentration of B is 10, rate is 2. Concentration of A is 20, concentration of B is 2, the rate is 4. The concentration is 10, concentration is 20, rate is 2. So what is this? This is rate. And these are the concentration of A and B. So in the numerical, they used to ask the concentration of A, B, C. These are the three cases. And rate as well as concentration is mentioned. And you have to calculate the order of A and B. So I can say rate can be written as K, A to the power X, B to the power Y. So we can able to write down that rate is equals to K, concentration of A is X, concentration of B is this. When the concentration of A and B are 10, 10, the rate is 2, I can say 2. When the concentration of A is 20, the rate is 4, again the concentration is 2, rate is 10. By solving these two equations, we can able to get the value of X and Y. If you divide equation 1 with 2, you can able to get the value of X equals to 1. If you divide 1 by 3, you can able to get the value of Y equals to 0. So by solving this, we can able to get the order of A and B, that is respectively 1 and 0. If order with respect to A is 1 and with respect to B is 0, we can able to say that this reaction is 1 plus 0 first order reaction mechanism. Is it clear? The second term which we use is molecularity. Molecularity is minimum number of collisions required to do the reaction at rate determining step. Or if you remove the statement from rate determining step, that is a minimum number of collision required to do the reaction. How to calculate molecularity? Again, the molecularity is the experimental data, just like order. How you define molecularity? If I write a reaction, for example, 2A plus 3B give rise to C. In the first step, A plus A react to form A. In the second step, B plus A2 gives D. In the third step, A2 plus 2B give rise to C. And assuming that the third is the rate determining step, slowest step. So molecularity is a very simple phenomenon. You just see in the third step, if A2 is 1, B is coefficient of B is 2, that means in the rate determining step, we required 3 molecules to collide. So the molecularity is 3. Like order, molecularity never will be 0 nor fractional. We cannot able to say that half molecule collide with each other. Clear? So molecularity is always in the number of 1 to 2, 3. The maximum molecularity is 3. Because if you say molecularity is 4, that means at the rate determining step, at least 4 molecules have to collide with each other. So the probability to collide 4 molecules are very rare. For example, in a container, if you are talking about a container which consists of molecules, so the collision of all 4 molecules at a point is very rare. So we say Molecularity above 3 is very rare. Clear? Now let us again consider a first order reaction kinetics. First order reaction mechanism or first order reaction kinetics. In the first order reaction mechanism, we can say A give rise to product P. So I can say minus dA upon dt can be written as K multiplied by A to the power 1. Why 1? Because I have told that this is first order reaction mechanism. So minus dA upon A can be written as KT. Now I am integrating this. When time t equals to 0, the concentration of A is A naught. When time t equal to t, the concentration is AT. That means by solving this, we can able to get K equal to 2.303 log A naught upon AT. This is a equation to calculate rate constant K. To calculate rate constant K for the first order reaction mechanism. That this equation is not valid for second, third order or zero order. So let us calculate first order reaction kinetics. So K can be written as 2.303 upon T log initial concentration by final concentration. What is A naught and AT? A naught is the initial concentration of A. AT is the final concentration of reactant A. If in a numerical, it is given that A give rise to product and the volume of the container is 1 liter. Volume of the container is 1 liter. And at time t equals to 0, the concentration of A is 10. At time t equal to 15 minutes, the concentration decreased to 8. Decreased to 8. What will be the rate constant K? You can able to say K equal to 2.303. T will be 15. After 15 minutes, the concentration decreases. So 2.303 upon 15 log A naught is the initial concentration, that is 10. AT is the final concentration, that is 8. So you can able to say that the rate constant K can be written as 2.303 upon 15 log 10 by 8. That will be the K. And the question which are asked are mainly, they rotate with this value because time there is no rotation. Rate constant K is very simple. You have to calculate the rate constant K. That means there are three variables, T, A naught, AT. T, A naught, AT. And in the question, these three variables are given and you have to calculate the rate constant K. But this is a very simple mode that at initial concentration I have mentioned, final concentration I have mentioned, time I have mentioned, you have to calculate the rate constant K. So the rotation start from these concentration A naught and initial and final. Is it clear? So let us take some example to how to calculate the rate constant K in different cases. In different cases. Let us consider a case 1. Calculation of rate constant K for a gaseous species. Let's say a container consists of A give rise to B plus C. A container consists of A give rise to B plus C. In this case, I am assuming that both A, B, C are in gaseous phase. At time t equals to 0, the pressure of A is P naught and the pressure due to B and C are 0, 0. Clear? So at time t equal to 0, pressure of A is P naught. After time t, the pressure of A is Pt. Pressure of A is Pt. So calculate the value of rate constant K. In the second case, the pressure of this container at time t equal to 0 is P naught. The pressure of this container, entire container, at time t equal to t is Pt. In this case, the Pt is the partial pressure of A. But in this case, Pt is the pressure due to container. That means all three. So you have to write down the rate constant K in both the cases in terms of P naught, PT and T. You have to write down the rate constant K in terms of P naught, PT and T. So the first case, what will be the rate constant K? In this case, you can say rate constant K is 2.303 upon T log P naught upon PT, initial pressure, final pressure of A. But in the second case, time T equals to 0, the pressure of P naught, this is 0, 0. After time T, the pressure of A is P naught minus X, this is X, this is X. So you can say the rate constant K will be 2.303 upon T log P naught by P naught minus X. So we have to substitute the value of X because we have to calculate the rate constant K in terms of P naught and PT. So I can say P naught minus X plus X can be written as PT. So the value of X can be written as PT minus P naught. Now substituting the value in the rate constant K, 2.303 upon T log P naught by 2 P naught minus PT. So this is the rate constant K in the second case. Clear? Clear? So let us consider one more case. Case 3, again for the same molecule, A give rise to B plus C. And the data are at time t equal to 0, the pressure is not mentioned. At time t equal to t is Pt. At time t equal to infinite, when the reaction complete, the pressure of the container is P infinite. So you have to calculate the rate constant K in terms of Pt and P infinite. In this case, can I say at time t equal to 0, the pressure is P naught 0 0. At time t equal to t, it is P naught minus x x x. At time t equal to infinite, it is 0. This is P infinite, this is P infinite. So we have to calculate the value of, actually the rate constant K can be written as 2.303 upon T log P naught by P naught minus x. Now we have to calculate the value of P naught and P naught minus x in terms of Pt and P infinite. So we can say, so this is P naught, sorry. We can say 2 P naught can be written as P infinite and P naught can be written as P infinite by 2. Whereas P naught minus x plus x can be written as Pt. So the value of Pt is P naught and it is Pt minus P infinite upon 2. By substituting this in the above equation, we can able to write 2.303 log. In place of P naught, I can say P infinite upon 2, P infinite upon 2 minus Pt minus P infinite upon 2. Is it visible? Clear? So in terms of pressure, if the initial, final or after time t, the pressure are given, you can able to calculate the rate constant K. Can you solve this? A give rise to B, C, D. The coefficient of A is A, B, C, and small d. A, B, C, D are small d and it goes to infinite. And the data given is at time t equal to 0, the pressure is P naught. After time t, the pressure is Pt. After time infinite, the pressure is P infinite. You have to calculate rate constant K in terms of P naught, Pt, and P infinite. The coefficient of A is small a. We don't know the value of A. You have to calculate rate constant K in terms of P naught, Pt, and P infinite. A, B, C are not given. You have to calculate rate constant K in terms of P naught, Pt, and P infinite. First of all, write the equation in terms of A, B, and C. मेरा भूल कर रहता है ना. ये है क्या? From these three equations, so see, B by A, C by A, D by A can be written as P infinite by P naught. Clear? B by A, C by A, D by A can be written as P infinite by P naught. B by A, C by A, D by A dash 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 can be written as P infinite by P naught. By substituting this value to this point, we can able to find the value of alpha in terms of P naught and P infinite. Again, if we get the value of P alpha in terms of P infinite, we can able to calculate the value of P naught and P naught minus alpha in terms of P naught, Pt and P infinite. You can solve it. So is it clear? So to calculate the value of rate constant K, there are different cases in which the pressure of different time is mentioned. From that particular pressure, you can able to find the rate constant K. Now let us take some example of solution. How to calculate the rate constant K if solution is given. Let us consider a equation where an ester undergo acidic hydrolysis in presence of H plus. Ester undergo acidic hydrolysis. You have to calculate the rate constant K for this particular reaction. Clear? To find the value of rate constant K, we have titrated this solution in three different stage. Just understand how we have titrated. All the three solutions are titrated with the help of sodium hydroxide having normality N. The normality of NaOH in all three cases are same. Clear? Now, this container consists of ester, water, H plus. All three container consist of ester, water, H plus in the same concentration. Having same volume. I have taken ester, water, H plus in this container. Second container consists of ester, water, H plus. Third container consists of ester, water, H plus. Having concentration of H plus, water and ester are same. But the only difference is the first container is titrated at time t equals to 0. The second container is titrated at time t equals to t. And the third container is titrated at time t equals to infinite. Is it clear? When the first container is titrated at time t equals to 0, V naught ml NaOH is used. Second container, Vt ml NaOH is used. Third container, V infinite ml NaOH is used. So you have to calculate the rate constant K for this particular reaction in terms of V naught, Vt and V infinite. Before solving this equation, you have to represent the expression in terms of A, B, and C. So, can I say at time t equals to 0. First of all, you have to rub this one. We have to solve this equation in terms of v naught, vt, and v infinite. Time t equal to 0. V naught ml NaOH is required. Time t equal to t. Vt ml NaOH is required. Time t equal to infinite. V infinite is used. So at time t equals to 0, I am assuming that the moles of esters are A, or concentration of ester is A. These two molecules are 0, 0. Clear? At time t equals to t, it is A minus alpha, alpha, alpha. At time t equal to infinite, it is 0, A. Is it clear? At time t equals to 0, जब time 0 था, at time t equals to 0, the container consists of three things. One is ester, second is water, third is H plus. Out of these three molecules, NaOH will react only with H plus. Being a strong base, NaOH always react with acid. Therefore, out of three molecules like ester, water, and H plus, NaOH at time t equal to 0 must react with this H plus. So I can say V naught, that is the initial volume, multiplied by the normality of NaOH is the equivalent of NaOH required, must be equals to A. This is first equation. Clear? When time t equals to t, the volume of NaOH required is Vt. At time t equals to t, there are five molecules: ester, water, H plus, carboxylic acid, and methanol. Being a strong base, NaOH react only with acid. Therefore, at time t, NaOH will react with this H plus and this carboxylic acid. And the carboxylic acid present at time t equal to t is alpha. Therefore, Vt multiplied by N can be written as H plus plus alpha. Sorry, this is H plus initial. This is the second equation. And after infinite time, V infinite, it react with H plus and A, because after time t equal to infinite, only carboxylic acid left is A, H plus. So A plus H plus, time t equal to t, alpha plus H plus, time t equal to 0, only H plus. So you can able to get the equation, three equations. Clear? Now see the reaction. In this reaction, if you want to calculate the value of rate constant K, what you required is 2.303 upon T log initial concentration of ester minus final concentration of ester, that is A and A minus alpha. Now you have to calculate the value of A. Now you have to calculate the value of A and A minus alpha in terms of V naught, Vt, and V infinite. So can I write rate constant K is 2.303 upon T log, in place of A, I am writing V infinite N minus V naught N. H plus cancel A. Clear? And in place of A minus alpha, can I write V infinite N minus V naught N minus alpha can be written as Vtn minus V naught N. Both N can be cancelled out. Now the final expression rate constant K can be written as 2.303 by T log V infinite minus V naught, and V naught cancel V naught. So V infinite minus Vt. So this will be the final rate constant K. Is it clear? Is it clear to all? कहाँ कहाँ जा रहा लेक्चर दिखाइए, बाकी बच्चों से पूछता है. हो सकता है, कहाँ भी हो रहा है, नाम बताइए किसी का। क्लियर? So this is one example when we use volumetric titration to calculate the rate constant K. Now we can say optical rotation. Optical rotation is directly proportional to concentration. Optical rotation is directly proportional to concentration. Higher the concentration, higher will be the optical rotation. So can I say with the help of optical rotation, we can able to calculate the value of rate constant K? Now consider a reaction A give rise to B plus C. A give rise to B plus C. The specific rotation of A is R naught 1. The specific rotation of B is R naught 2. The specific rotation of C is minus R naught 3. Clear? The specific rotation of A, B, and C is R naught 1, R naught 2, and R naught 3. What is specific rotation? When you take concentration of A, 1 molar, it rotates plane polarized light to R naught 1 direction. When you take, so how you define specific rotation? It is the rotation when the concentration of the reactant is 1 mole or 1 mole per liter. Concentration is 1 molarity. Now, we have to calculate the rate constant K with these three values. At time t equals to 0, the rotation is R naught, time t equal to t, rotation is RT, time t equal to infinite, the rotation is R infinite. In terms of R naught, RT, R infinite, we have to calculate the value of rate constant K for this reaction. But in the rate constant K, R naught 1, 2, and 3 are not mentioned. That means in the question, this R naught 1, R naught 2, R naught 3 is not given. I am giving a hint how to use R naught 1, R naught 2, R naught 3. Actually, what is R naught 1? When you take 1 mole of A, the optical rotation is R naught 1. If you take X mole of A, the optical rotation will be X R naught 1. Clear? Clear? So if this container consists of 10 moles of A, the optical rotation will be 10 R naught 1. When time t equals to 0, the optical rotation is R naught. When time t equal to t, the optical rotation is RT. When time t equal to infinite, optical rotation is R infinite. So you have to calculate the rate constant K in terms of R naught, RT, R infinite. Question is clear? So can we write at time t equals to 0, the concentration of A is small a, B and C are 0, 0. At time t equal to t, it is A minus X. This is X, X. At time t equal to infinite, this is 0, A. So to calculate the value of rate constant K in this equation, we can write rate constant K is 2.303 upon T log A by A minus X. A by A minus X. So what we required A and A minus X in terms of R naught, RT and R infinite. So can I say if 1 mole of A rotate plane polarized light to R naught, 1 mole of A rotate plane polarized light to R naught, A will rotate A R naught 1. 1 mole of A rotate plane polarized light to R naught. A will rotate A R naught 1, and it is given that A R naught equals to R naught. At time t equal to 0, the rotation is R naught. How to calculate the order of reaction from a given equation? Okay, let I complete this. After that, we will discuss how to calculate the order of reaction. So A R naught 1 equal to R naught. This is the first equation. After time t, A minus X multiplied by R naught 1 plus X into R naught 2 plus minus X R naught 3 can be written as RT. This is second equation. Is it clear? A minus X multiplied by R naught 1, X into R naught 2 minus X into R naught 3 is RT. This second equation can be rewrite as A R naught 1 minus X R naught 1 plus X R naught 2 minus X R naught 3 is RT. So A R naught 1, I can able to write R naught minus, if X taken as common, it is R naught 1 minus R naught 2 plus R naught 3 is equals to RT. So I can able to say that X, the value of X can be written as R naught minus RT upon R naught 1, R naught 2, R naught 3. Is it clear? So third equation at the infinite equation can be written as A R naught 2 minus A R naught 3 is equals to R infinite. This is the third equation. Any doubt? For 1 mole of B, the rotation is R naught 2. For A, it is A into R naught 2. For 1 mole of C, the rotation is minus R naught 3. For A, it is A R naught 3. That is equal to R infinite. This is the third equation. If I subtract the first equation to third, the expression is A R naught 1, A R naught 2, A R naught 3 can be written as R naught minus R infinite. So the value of A can be calculated as R naught minus R infinite upon R naught 1, R naught 2, R naught 3. Is it clear? Now we have get the value of X as well as A. Now we have to calculate the value of rate constant K. K equal to 2.30 by T log initial by final A by A minus X. So we have to substitute the value of A with R naught minus RT, A minus X. This is the value. So this equation can be rewrite as K equals to 2.303 upon T log. In place of A naught, I am writing A R naught minus R infinite by 1. Why 1? This part I have written 1. A minus X again, R naught minus R infinite minus the value of X, R naught plus RT by 1, 1 cancel. So the final expression rate constant K can be written as 2.303 upon T log R naught minus R infinite, and it is R naught cancel, RT minus R infinite. Is it clear? Is it visible? क्वेश्चन कहाँ से आया? Should I rub the board? Eh? So let I repeat the concept of calculation of order with respect to chemical reaction for aggression. Aggression, I think the name of the school is aggression. So let us consider a reaction 2A plus 4B give rise to C. 2A plus 4B give rise to C. If you'll see the mechanism, the step 1, A react with this A to give A2. In step 2, A2 react with 2B to give D. In step 3, 2B react with this D to give E. And it is given that third step is the rate determining step. Third step is the rate determining step. So to calculate the order of this reaction from the mechanism of this particular reaction, we have to write down the reaction mechanism which is mentioned in the question. And the third step is the rate determining step is also mentioned in the question. So in this case, I can able to say the rate law is rate equals to K3 multiplied by B square multiplied by D. If in the rate determining step, the coefficient is directly the order. So B is the molecule and 2 is the coefficient. So I have written B square into D is the rate. But in the final equation, D is not present. It is an intermediate. So we have to replace this D. To replace D, we have to take the step 2. Every reaction are in equilibrium. So this rate can be written as K3 B square. In place of D, can I say Kc2, the second equilibrium constant, is D by A2 multiplied B square. Now the expression of D can be written as Kc2 A2 into B square. Now again there is a molecule which is not present in the final equation, and that is A2. So we have to replace this A2. Now the rate law can rewrite as K3 B to the power 4 Kc2. In place of A2, I am writing Kc1 A square. Now, if I replace all the rate constant K with capital K, the expression is B to the power 4 A to the power 2. So net order is 6. So by this way, we can able to calculate the order of reaction through chemical reaction. So first select the rate determining step, write down the rate determining step, replace all the intermediate through above equation. Finally, if you get the rate law with the molecule which are present in the normal or parent reaction, the power of any molecule is the respective order of that particular reaction. Is it clear? Any other doubt? बाकियों के लिए भी पूछ रहा हूं. So we have calculated rate constant K for different reactions, different cases. Now let us consider some parallel reactions. Let us assume that A give rise to B, and this A gives C. This is known as parallel reaction. Why parallel? Because A produces B, simultaneously A gives C. So first of all, what is the difference between this reaction A gives B plus C and A gives B, A gives C? This is a normal reaction. In this case, if I take 10 moles of A, after some time, 8 moles of A left, you will say moles of B form 2, moles of C form 2. Initially, both are 0. Rate constant is K1. This rate constant is valid for B as well as C. I can say rate of disappearance of A in this case is always equals to rate of appearance of B equals to rate of appearance of C. So rate of disappearance of A in this equation minus dA by dt, as mentioned earlier, can be written as dB by dt, can be written as dC by dt. So rate of disappearance of A equals to rate of disappearance of B equals to rate of disappearance of C. But in this case, there are two different reactions having different rate constant, K1, K2. The rate constant are different. That means there are two different reactions which are merged. Now, if I take the initial concentration to 10 moles, initially both B and C are 0. After some time, if moles of A left is 6, that is not necessary that moles of B and C are equal. It depends upon the rate constant K1 and K2. If K1 is higher, the concentration of B must be higher than C. If K2 is higher, the concentration of C must be higher than C. Secondly, the rate of appearance of B and C are not equal. In just like in this equation, dB by dt is equal to dC by dt. So if from 10 mole it decreased to 6 mole, so we can able to say that it might possible B will form 3, C will form 1. But if you add the concentration of B and C, it must be equal to the rate of disappearance of A. So I can say in this case, minus dA by dt is the rate of disappearance of A, can be written as dB by dt plus dC by dt. That means rate of appearance of B plus rate of appearance of C equals to rate of disappearance of A. Is it clear? So minus dA by dt equal to dB by dt plus dC by dt. कहां से क्वेश्चन है? दोबारा क्वेश्चन कहां से? ठीक है ठीक है. Explain again the concept of finding rate constant using optical rotation. Okay, after this concept we can able to explain in short. Minus dA by dt is the rate of disappearance of A, can be written as dB by dt plus dC by dt. So, but in that case, minus dA by dt can be written as dB by dt plus dC by dt. Can I say dB by dt is K1 into A? Yes. But dC by dt can be written as K2 into A. Similarly, minus dA by dt can be written as K1 plus K2 into A. Any doubt? Is this concept is clear? So, dC by dt is K2A, dA by dt is K1 plus K2 into A, dB by dt is K1A. Is it clear? Let us consider one reaction like this. A give rise to B, B give rise to C. The rate constant for the first reaction is K1 and the rate constant for the second reaction is K2. In this case, can I say minus dA by dt? Minus dA by dt means rate of disappearance of A. Can I say minus dA by dt, that is rate of disappearance of C? A is mainly depend upon the concentration of A. If you increase the concentration of A, rate of disappearance of A increases. So minus dA by dt can be written as K1 multiplied by A. Similarly, dB by dt. dB by dt. What is dB by dt? Rate of change of concentration of B with respect to time. Can I say if 10 moles of A form, 5 moles of B reacted. Sorry, 10 moles of B form and 5 moles of B reacted. That means dB by dt is 5. That means how you define dB by dt? Rate of formation of B minus rate of disappearance of B. So dB by dt can be written as K1A. This is the amount of B form. Similarly, K2B, this is the amount of B reacted. So dB by dt can be written as K1A minus K2B. And dC by dt can be written as K2B. Is it clear? Is it clear? The concentration graph with respect to time is A, the concentration constantly decreases. B, the concentration first increases, then decreases. C, the concentration always increases. Clear? Concentration of A always decreases because initially it is very high, slowly it decreases. Concentration of B, initially it increases because rate of appearance must be higher. But as soon as the concentration of B increases, the rate of disappearance also increases. So that after some time, the concentration of B is maximum. You can able to calculate the value of time when the concentration of B is maximum. We can able to calculate when dB by dt equal to 0. dB by dt equals to 0. That will be the time at which the concentration of B is maximum, according to concept of maxima and minima. Similarly, we can able to calculate the value of C also. Is it clear? Is it clear? So I am writing some questions. Write down dA by dt, dB by dt, dC by dt in terms of K1, K2 and K3. In this case, write down dA by dt, dB by dt, dC by dt, all three cases. I am again explaining the concept of optical rotation. All the students who have already understood, solve this question. And the people who have doubt in the optical rotation, I am explaining again. Look, A give rise to B plus C, R01, R02, R03. The data given are, at time t equal to 0, it is R0. Time t equal to t, it is RT. Time t equal to infinite, it is R infinite. So you can say, we have to calculate rate constant K. We have to calculate rate constant K with respect to R0, RT, R infinite. How you define R01, R02, R03? R01 is the optical rotation due to 1 mole of A. R02 is the optical rotation due to 1 mole of B. R minus R03 is the optical rotation due to 1 mole of C. Now, I am assuming that time t equal to 0, it is A. This is 0, 0. Time t equal to t, this is A minus X. This is X, X. Time t equal to infinite, this is 0. This is A, A. Now, can I say the rate constant K is 2.303 by T log A by A minus X. Now we have to calculate the value of A and A minus X with respect to R naught, RT and R infinite. Is it clear? What is the name of that school? Mahatma Montessori. Mahatma Montessori student, is it clear? A by A minus X. Now we have to calculate the value of A and A minus X in terms of R naught, RT, R infinite. Can I say, if I take 1 mole of A, the optical rotation is R naught 1. For 1 mole of A, the optical rotation is R naught 1. For A mole, the optical rotation is A R naught 1. So I can say A R naught 1. A R naught 1 equals to R naught, because at time t equal to 0, the rotation is R naught. Similarly, for 1 mole of A, rotation is R naught 1. For A minus X into R naught 1, X into R naught 2, X into R naught 3 can be written as RT. Finally, A R naught 2, A R naught 3 can be written as R infinite. So I have calculated these three equations. From these three equations, you calculate the value of A and X in terms of R naught and RT, R infinite, and applied in this equation, you can able to get the value of rate constant K. This is a simple mathematical calculation after that. Is it clear? So let us solve these three equations in terms of K1, K2 and K3. So in the first equation, as mentioned earlier, I can say minus dA by dt equals to K1A. dB by dt can be written as K1A minus K2B. dC by dt can be written as K2B. Is it clear? Is it clear to all? All. In the second equation, minus dA by dt can be written as K1A. This is for first. Minus dA by dt K1A. dB by dt can be written as K1A minus K2C plus K4D. K2B, sorry. Clear? Similarly, dC by dt can be written as K2B minus K3C. Clear? Is it clear? So this question can also be solved same manner. Any doubt? Any doubt? महात्मा गांधी से पूछ लो. So let us solve a question based on parallel reaction. A give rise to B, A give rise to C. This is rate constant K1, this is rate constant K2. The data given is K1, 2 second inverse, K2, 4 second inverse. You have to calculate after 15 seconds. After 15 seconds, what will be the concentration of C by AT? I'm repeating the question again. This is a parallel reaction in which A gives rise to B, A gives rise to C. This is rate constant K1, this is rate constant K2. And it is given that the value of K1 is 2, K2 is 4 seconds. Initially, I have taken A. Let's say I have taken A 10 moles, but 10 mole is not mentioned in the question. So the container consists of A with X moles. After 15 seconds, this container consists of A, B, C, because B and C parallelly forms. So you have to calculate what will be the ratio of this C upon the concentration of A left after 15 minutes. Sorry, 15 seconds. So the concentration of C by concentration of AT after 50 seconds is So anyone can explain? Can I say dB by dt in this equation is K1 into A, whereas dC by dt is K2 into A? So I can say dB by dC is equals to K1 by K2. That means concentration of B by C can be written as K1 by K2, that is 2 by 4, 1 by 2. Is it clear? I can say minus dA by dt is K1 plus K2 into concentration of A. That means K1 plus K2 can be written as 2.303 upon T log A naught by AT. At time t equals to 0, if I have taken it is A naught minus x minus y, x and y are the concentration of B and C. So can I say A naught minus x minus y is AT? That means in place of A naught, I can say x plus y. So this expression, that is 6 equals to 2.303 upon 15 log, what is the value of A naught? This is AT plus x plus y upon AT. What is x? It is B. Can I say x by y is 1 by 2. Therefore, x can be written as y by 2. So this above expression can be solved as 6.023 by 15 log AT plus y by 2 plus y by AT. From this equation, by taking the anti-log, I can able to solve the value of AT by y. Is it clear? Is it clear? So we know that how to change the rate constant K. This rate constant K is depend upon several factors. For example, let us consider a reaction in which carbon monoxide react with oxygen to give carbon dioxide. And we are considering this equation rate constant K, in which carbon monoxide react with oxygen to give carbon dioxide. This reaction needs certain activation energy, then this is product. So this is reactant, this is product. This is what we called activation energy for forward. This is activation energy for backward. The difference is enthalpy of reaction, and this is what we call transition state, and this is threshold energy, the total energy of the transition state. Clear? For a reaction, there must be some barrier. Reactant gives product only when it achieves this transition state. That means you have to provide this activation energy. The rate constant K can be defined as when you take 1 mole of carbon monoxide with 1 mole of oxygen and provide sufficient activation energy, it will reach to this point and then come back to the product, and that will be the rate constant K. Now consider this, for the same reaction, if I decrease the activation energy, for the same reaction if I decrease the activation energy. How you define the activation energy? The amount of energy which is required to break the bond between O and O, because this O and O bond break, when bond of oxygen and carbon form, there must be energy which is released. This is the energy which is released when carbon and oxygen bond form. To break this O and O bond, we require some amount of energy. The amount of energy required to break this bond is known as this activation energy. If we decrease the bond dissociation energy of O and O by adding some catalyst which absorb the pi clouds and decrease the bond strength, the activation energy decreases. Now, if the activation energy decreases, what is the effect on this rate constant K? एक्टिवेशन एनर्जी कम होगी तो रेट कांस्टेंट के बढ़ जाएगा क्योंकि जल्दी पहुंच जाएंगे. सो इफ यू डिक्रीज द एक्टिवेशन एनर्जी, द रेट कांस्टेंट के increases. So can I say rate constant K is inversely proportional to activation energy? Second thing, when this reaction occurs, there must be one more thing, which is known as collision. Both are gaseous. This is also collide. It might possible it collide with this carbon. So there are ineffective collision and effective collision which gives the product. So if you increase the effective collision, the rate also increases. So rate constant K is also depend upon effective collision, which is represented by Arrhenius constant A. Third is temperature. If you increase the temperature, rate constant K for almost all reaction increases, because increasing the temperature, the reactant achieves this transition state in the lesser number of time. But increasing the temperature does not mean this activation energy decreases. Activation energy remain constant, but the time required to reach this activation stage is faster. So I can say rate constant K can be written as A e to the power minus EA upon RT. EA is the activation, R is gas constant, T is temperature, A is Arrhenius constant. So rate constant K can be written as A into EA by RT. Is it clear? So we can able to solve this some numerical based on Arrhenius equation and the temperature factor. I know all the equation with K1, K2 you already read in the class 12, right? So let us discuss something about the radioactive element. Why radioactive element? Because all radioactive disintegration follow first order kinetics. So almost all radioactive element or radioactive disintegration are first order reactions. We don't know the exact reason of the element, why the element are radioactive. But we can do a simple experiment. Let's say periodic table consists of 118 elements. Okay? Out of that 180 element, we know these are the elements which are radioactive. So how we know that these elements are radioactive? This is experimental data. Now I have plotted a graph neutron and proton ratio. The first element is the exceptional case, that is hydrogen. Let's start with second element, helium. I can able to check whether helium is radioactive or not. We have checked that helium is not a radioactive element. Now, number of proton in helium is 2. Number of neutron in helium is 2. So N by P is 1. So I have made experimental data with this graph. The point where N by P is in the stable zone. The point where N by P in the stable zone. So for 2 protons, 2 neutrons, it lie in this position. So it is a stable. I have plot almost all 118 elements. What observation I have found, with the higher atomic number, the stability zone is higher than 1 by n by p is 1, but the stability zone is higher than 1. Is it clear? So if I say I have 80 protons, and this nucleus consists of 80 neutrons. So this element, 80 proton, 80 neutron, n by p is 1, but the stable zone is 1.3. So I will say this element is a radioactive element. So all elements which lie in this graph are stable. All elements which lie below this graph or above this graph are radioactive. Is it clear? This graph is strictly based on experimental data. So can we say with the lower atomic number, like 1, 2, 3, 4, the element are n by p 1 is the stable form, but with the higher atomic number, the n by p must be greater than 1. It might possible it is 1.1 to 1.6, the stability zone. If the element lie below or above the stability zone, the element must be radioactive. Is it clear to all? So let us consider an example of an radioactive an atom consists of one hundred proton and 100 neutrons. 100 proton, 100 neutron. This is the assumption. And we say it consists, the atomic number is 100, the atomic mass is 200. Is it clear? Now see, proton is 100, neutron is 100, so n by p is 1. As I earlier discussed that if n by p is 1, it must be a radioactive element. So n by p is 1, it is a radioactive element. Now to stabilize this element, the n by p must be higher than 1. How to make higher than 1? So we have to increase neutrons and we have to decrease this proton. So what is the purpose of this nuclei? To decrease the number of proton. Is it clear? It consists of an electron outermost shell. As you know, the first orbit 2 electron, second orbit 8, 18, like this. Electronic configuration. Clear? Proton and neutron, apart from this proton and neutron, the nucleus consists of one meson particle. Meson are of 3 types: pi positive, pi negative, and pi neutral meson. Why this ratio is important for a radioactive element? Actually, what happened? One proton is positively charged. When it absorbs pi negative meson, it is converted to neutron. That means every proton is converted to neutron by absorbing a pi negative meson, and every neutron is converted to proton by releasing one pi negative meson. The conversion occurs in very fast speed. Therefore, the intensity of a positive charge at particular point decreases and the interprotonic repulsion minimizes. This way, the nuclear stability increases. But in some cases, if the ratio between proton and neutron are disturbed, the equilibrium rate decreases. Due to this, the intensity of positive charge at particular point increases and repulsion between proton-proton increases. Such nuclei are known as radioactive nuclei or unstable nuclei. To stabilize such nuclei, we have to convert or we have to reduce the n by p to the stable zone. So in this example, I have taken proton 10, neutron 10, and it consists of 3 meson particles, pi negative, pi positive, and pi neutral meson. We know that in this case, n by p is 1, and we have to increase the value of n by p. Is it clear? Now what happened? Electron from the first orbit is absorbed by this nucleus. First orbit के इलेक्ट्रॉन न्यूक्लियस के अंदर आ गए and this electron and proton combine to form neutron. And this is what we call electron capture. When electron come inside the nucleus, the energy is released in the form of electromagnetic radiation. And that particular electromagnetic radiation is known as X-ray. And this phenomenon is known as electron capture. So due to electron capture, number of proton reduced by 1 unit and number of neutron increased by 1 unit. So it is the number of proton from 100 converted to 99 and number of neutron from 100 converted to 101. But the atomic mass remain constant. Is it clear? This is what we call electron capture. Now, again, after one electron capture, you can able to see number of proton is 99, number of neutron is 101, and the N by P ratio is higher than 1. It might possible N by P reaches to the stability zone. It might also possible it unable to reach the stable zone. So again, it will release or absorb one electron till it get stabilized. So electron capture stabilizes the nuclei and the N by P ratio reaches to the stability zone. Now you can see why we are reading this radioactivity in chemical kinetics. You can say the identity of an atom is represented by the number of proton. If an atom consists of 1 proton, we say hydrogen. If an atom consists of 2 proton, we say helium. Now, in this atom, the number of proton are 100. When electron capture occur, number of proton are 99. So the identity of that particular atom changes. So this is a particular chemical reaction in which A is converted to B. We are reading the rate constant and the rate of this A to B. Clear? Now consider the reaction where number of proton do you know what is beta emission? In this case, A N by P is 1. What is our intention to stabilize this? N by P must be greater than 1. We have taken one electron capture. There is one more possibility apart from electron capture, and that is one neutron is converted to one proton and release one pi negative meson. Is it clear? If this happens, now this A is converted to again B. Number of proton are 101. Number of proton are 101 and number of neutron decrease by 1 unit. But this molecule will not release this beta emission because we have to increase the N by P. By beta emission, we are decreasing N by P. But there are some example like if the number of proton is 50, number of neutron are 80, the value of N by P is 8 by 5. It is approximately 1.4 and the stability zone lie at 1.2. So we have to decrease the value of N by P. In this case, what happened? One neutron is converted to one proton plus one electron. One electron means through the help of pi negative meson, and the number of proton now increased to 51. Number of neutron might decrease to 79, and one electron or negatively charged particle releases. This is what we call beta emission. Is it clear? So beta emission decreases the N by P, whereas electron capture increases the N by P. Alpha emission is number of proton, 2 neutron release. It also increases the value of N by P. Is it clear? In all emission alpha, beta and gamma, there is lot of energy exchange occurs which release electromagnetic radiation in the form of gamma radiation. Is it clear? Now, what is the use of radioactivity in chemical kinetics? You can able to calculate the number of alpha radiation emitted, number of beta emission. Let us consider a radioactive disintegration A give rise to B by releasing one beta radiation. Clear? The rate constant K for radioactive element is represented by lambda. Lambda can be written as 2.303 upon T log. In general, we write initial concentration by final concentration. But in radioactive disintegration, both initial concentration and final concentration represented for A. The volume remain constant. Therefore, we can able to write down number of moles of A by number of moles of A finally. That means if 10 moles of A, initially the moles of A is 10. After 10 minutes, the moles of A is 5. We can write moles of A 10 by 5. You know, number of mole. How do you define number of mole? Weight by molecular weight. So both are A. Therefore, can we write initial weight of radioactive element A by final weight of radioactive element A? Is it clear? Or you can write number of nuclei of initially A by number of nuclei initially, sorry, after time T. We can able to write initial nuclei, we can able to write initial weight, we can able to write initial number of moles. Is it clear? Now, let us assume that this is a radium. Both are radium. Small radium, larger radium. Now, I have seen in 1 second, this radium disintegrate 10 alpha ray and 5 beta ray. So I will say the radiation emitted per unit time is 15. This is called disintegration or activity. This is called activity. I am saying that it emit 20 radiation, 20 disintegration. It might possible that 20 disintegration may be alpha or beta, or maybe alpha plus beta plus electron capture, whatever that will be. If 15 radiation is emitted, I will say the activity is 15 radiation per second. These are the two radium. Which radium have higher activity? This one or this one? Higher. Chota, bada. Which radiation have higher activity? Alpha, beta and gamma radiation are emitted from nucleus. This consists of larger number of nucleus. This consists of smaller number of nucleus. So which radiation is higher? This one. Can I say number of nuclei disintegrated per unit time is directly proportional to number of nuclei present? Higher the number of nuclei, higher will be the disintegration, because disintegration are originated from nucleus. So d naught upon dt can be written as lambda into n naught. Similarly, dt can be written as lambda into nt. Is it clear? And d naught by dt is known as initial activity. So I can say initial activity is lambda into n naught. Final activity is lambda into nt. So can I write in this equation, if n naught by nt I can able to write initial activity by final activity. So to calculate lambda, we can use initial mole, final mole, initial weight, final weight, initial nuclei, final nuclei, initial activity, final activity. So they will given you initial weight, final weight, or anything these apart from these four. You have to calculate the value of lambda or half-life period. How can you calculate the half-life period? As you know, 0.693 by K. How 0.693? A naught, N naught by N naught by 2. So log 2, if you solve it will come 0.693. Is it clear? Is it clear? Any doubt? Any doubt? Mahatma Gandhi School? What is the use of radioactive disintegration? Let's say this is an object thousands of year old. We have to calculate the exact age of this object. Clear? How to calculate the exact age? I have taken a small portion of this marker, analyze. Today I have seen that it consists of two radioactive elements. One is uranium 235 and other is polybdenium 169. We know polybdenium is a radioactive element which is obtained from uranium. Today in this object we have find uranium 0.5 gram, polybdenium 0.2 gram. If the T half of uranium is 2170 years, find the age of this marker. Solve it. क्या है? अभी बोलेंगे तो आवाज जाएगा. KV Tripura. The question is the most of the element ratio of n by t is greater than 1 and the element are Ra is an unstable. Actually, the value of n by p represents the stability. It is not necessary that n by p greater than 1 is always unstable. For the value of neutron and proton, if I say neutron by proton, we cannot able to say that n by p 1 is stable, or n by p is greater than 1 is stable, or n by p is less than 1 is stable. The definition of stability is different for different number of atoms. If we will solve this question, if you can find atomic number less than 10, for atomic number less than 10, the value of n by p is 1. But if you say you are going to take the uranium, the value of n by p is must be greater than 1 or 1.5. Why it is so? Because you can see proton and neutron are interconvertible, and there is a fixed ratio of n by p which is increase the stability of interconversion due to meson particle. If this n by p is disturbed, the equilibrium is disturbed and the proton-proton repulsion is higher. In that case, due to interprotonic repulsion, the nuclei are highly unstable. So the value of n by p in most of the element is higher than 1. If it is lie in the stability zone, it is the stable. If it is above the stability zone, unstable. Below the stability zone, unstable. So you cannot say the value of n by p is 1, it is stable, or higher than 1, it is stable. It is defined for individual atoms. Is it clear, Tripura? If you still have any doubt, please write down your question. So today, if we say uranium and polybdenium, the weight is 0.5 and 0.2. We have to calculate the age of this marker. Can I write 0.693 upon 2170 equals to 2.303 by T log initial weight by final weight? Can I say final weight is 0.5? So we have to calculate the initial weight. If we can able to calculate the initial weight, easily we can able to calculate the age of this marker. Now, what will be the initial weight? Initial weight must be 0.5 plus something which is decayed. The weight is reduced due to the formation of this polybdenium. 1 mole of uranium produce 1 mole of polybdenium. So if 0.2 gram polybdenium is produced, that means 0.2 by 169 mole uranium is reacted, multiplied by 235 is the weight of uranium which is decomposed. This is the weight of uranium which is decomposed. This is the weight of uranium which is left. So initial weight of uranium must be 0.5 plus this. So this is the initial weight. This will be the final weight. You can able to calculate the time. And the time will be the age of that particular marker. Is it clear? Let us consider a reaction. A is a radioactive element. Upon alpha disintegration, it gives B. Upon beta disintegration, it gives C. Upon electron capture, it gives D. This is a perfect example of a parallel reaction in which A is converted to B by alpha disintegration, A is converted to C by beta disintegration, A is converted to D by electron capture. We have analyzed the percentage of product of B, C, D. Assuming that B is about 20%, C is about 65%, and this is about 50%, 15%. Clear? This percentage is based on products. The rate constant for the first lambda 1, second is lambda 2, third is lambda 3. If the half-life of this A, T half, is 15 minutes, then find out lambda 1, 2, and 3 value. Find out the value of lambda 1, 2, and 3. A is a radioactive element after 15, T half is 15 minutes. You have to calculate the rate constant lambda 1, 2, and 3.
ये ले लीजिए।
This is a parallel reaction. This is a parallel reaction. Can I say dB upon dt can be written as lambda 1 into A. dC upon dt is lambda 2 into A. dd upon dt can be written as lambda 3 into A. Is it clear? So, can I say if we divide these equation, then lambda 1 upon lambda 2 can be written as 20 by 65, whereas lambda 1 into lambda 3, so divide 3, can be written as 20 by 15, and lambda 2 by lambda 3 can be written as 65 by 15 based on the above three equations. Clear? And the rate constant lambda for A is lambda 1 plus lambda 2 plus lambda 3, which can be written as 0.693 divided by 15. So we have 1, 2, 3, and 4 equations. From these 4 equations, we can able to calculate the value of lambda 1, 2, and 3. So is it clear to all? We wind up our session. So best of luck for your board exam. Thank you.
Okay. Good afternoon, students. Today we'll start the chapters matrices and determinants, and plus mathematical reasoning. ठीक है? So first we will discuss our first question. These are the two important chapters in AIT JEE mains. ठीक है? Minimum to 2 to 3 questions come generally in this, and mathematical reasoning only one question will come. Okay, this is the weightage of these two chapters. So let's start with our first question of these chapters. This is the first question. Consider the statement negation of P, that is equivalent sign, and negation of Q. So check whether if it is equivalent to P equivalent to Q, and check whether if it is a tautology or a fallacy. You have to make the truth table of आता है ये नहीं सी देखो इधर क्वेश्चन इज negation of P, this means logically equivalent to, and this is negation of Q. To start this question, first make P and Q, है ना? Write make the truth table: true true, true false, false true, and false false. ठीक है? Let me explain सबसे पहले कि if P and Q are this, P and Q will be true और true का होगा true, true and false का false. ठीक है? And gate, which I've also studied in semiconductor also. ठीक है? False and true, false, 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 false. ठीक है? So if the intersection is between and is between true and true, the answer will be true, and otherwise it will be false. ठीक है? For P or Q, this is and gate or and. ठीक है? P और Q में true will become true or false will become true, false or true will become true, and false become false. This is or gate. ठीक है? So are they equivalent? Intersection P and Q and P or Q, they are not equivalent. ठीक है? T F F F, this is T T T F, so they are not equivalent. Now tell me, ठीक है? This is implies to sign, implies to. ठीक है? इसका मतलब है कि if and then, if P then Q, implies to. Okay, if P then Q. ठीक है? इसको हम ऐसे भी लिखते हैं स्लैश, यू कैन राइट इट लाइक दिस ऑल्सो, सॉरी, डबल एरो, एक ही बात है. नाउ सी, ट्रू का जो होगा इट इज ट्रू एंड फॉल्स इट विल बिकम फॉल्स. यू हैव टू रिमेंबर दिस टेबल, ओके, फॉर ईच एंड एवरी. एंड और implies to. False true will become true, and false will become also true. ठीक है? In this case only one false is there when P statement is true and Q statement is false. यानी if P then Q, if true then false will become false. बाकी सब cases में it will become true. ठीक है? And the last one is which is logically equivalent. That means if and only if, which is this P this arrow. ठीक है? Or you can write this. एक ही बात है. ठीक है? In this case true will become true false will become false true will become false, and false will become true. These are the 4 logical gates, 4 truth tables that you need to remember for IIT JEE mains. ठीक है? negation का मतलब आपको मालूम है, जस्ट उल्टा. negation, what is negation of P? false false, true, true. What is negation of q? false, true, false, true. ठीक है, तो ये ध्यान रखना. एंड गेट का याद रखना. एंड गेट मींस जब ट्रू एंड ट्रू होगा तभी ट्रू होगा, बाकी इन ऑल द टाइम्स इट विल बिकम फॉल्स. और वाले गेट में पी और क्यू में ट्रू ट्रू विल बिकम ट्रू, ट्रू फॉल्स ट्रू. ठीक है, सिर्फ फॉल्स होगा एक केस में, फॉल्स एंड फॉल्स में. इंप्लाइज ट्रू में इट विल, देयर इज ओनली वन फॉल्स व्हेन पी इज ट्रू एंड क्यू इज फॉल्स. और इस वाले में दे आर ट्रू इफ बोथ आर ट्रू एंड इफ बोथ आर फॉल्स. बाकी दोनों केसेस में फॉल्स है. तो ये लिख लो. तो आगे जो भी क्वेश्चंस आएंगे इनकी आपको, you will need them. ठीक है. Now let's make the truth table for this negation of p, negation of whole of p conditional of minus negation of q. So please make the truth table for the above statement. ठीक है, उसके बाद हम फर्स्ट एंड सेकंड we will check about the first statement and the second statement. इसको मिटा दूं. हैव यू रिटन? लेट्स स्टार्ट अगेन विद दिस p implies p if and only if negation of q. Let's start with this. अच्छा चलो, I want this p then negation of q. ठीक है, what is negation of q? देखो इधर, negation of q false, true, false, true. now मुझे इसका चाहिए implies to. ठीक है ना, सॉरी conditional, this logical equivalent to negation of q. बताओ क्या आएगा? true false, it is false. अभी मैंने बताया it is true only when if both are false, if both are true. ठीक है, so false, true true का true, false and false का true, false true का false. अब इसका भी नेगेशन, नेगेशन ऑफ दिस थिंग, नेगेशन हो जाएगा ट्रू, फॉल्स, फॉल्स, ट्रू. ठीक है, द फर्स्ट स्टेटमेंट इज चेक वेदर इफ इट इज इक्विवेलेंट टू पी कंडीशनल क्यू. ठीक है, पी इक्विवेलेंट टू क्यू. अच्छा, पी और क्यू का क्या बनेगा? पी एंड क्यू का अभी बताया हमने, ट्रू, ट्रू फॉल्स का फॉल्स, फॉल्स ट्रू. So they are both equal. That means the first statement is true. Understood? What do you mean by if it is a tautology or a fallacy? Tautology means if all the four parts are true. Fallacy means if all are false. So tautology means if all the four truth tables are true, all the four statements are true, and fallacy means all are false. So check whether this thing is a tautology or a fallacy. अभी कर दिया हमने ये. ऊपर वाले का बताओ, ये आ रहा था TFFT. So it's neither a tautology nor a fallacy. ठीक है, because TFFT आ रहा है, that's why. ना तो tautology means TTT. This is tautology. And fallacy means false, false. So ये कुछ भी नहीं है. Neither a fallacy nor a tautology. Understood? तो वो चीज आपको ट्रुथ टेबल यू हैव टू रिमेंबर, ताकि आप चेक कर सको whether it's equivalent to something or tautology or a fallacy. ठीक है, this type of questions come in IIT JEE mains. Next. If A is a 3 by 3 singular matrix, it's a question of matrices, such that AA dash means transpose of the matrix, is equal to A dash A and B is equal to A inverse A dash. So prove that BB dash is equal to identity matrix. Okay, I have given you prove that, but in the question, in the paper, it will come in the options. Okay, na? BB dash is equal to, let's say, BI. The four options will be there. So if A is a 3 by 3 non-singular matrix, mod A is not 0. A dash is A dash A, that means A dash is a symmetric matrix, and B is A inverse A dash. So prove that BB dash is equal to I. B is A inverse A dash, and BB dash, you have to prove BB dash is equal to I. BB dash is equal to I means it's an orthogonal matrix. ऑर्थोगोनल मैट्रिक्स में ही PB डैश की वैल्यू I के इक्वल होती है. हुआ? जस्ट वर्क फॉर LHS है ना. BB डैश, B इज A इनवर्स A डैश और B डैश हो जाएगा उस पूरे का ट्रांसपोज. और ट्रांसपोज की प्रॉपर्टी यू नो, AB का होल डैश इज इक्वल टू B डैश A डैश, एंड यू हैव टू यूज दिस प्रॉपर्टी आल्सो. A डैश इज इक्वल टू A डैश A. and use also you can use the property A inverse का whole dash is A dash का inverse है ना. ट्रांसपोज का इनवर्स इज इक्वल टू इनवर्स का ट्रांसपोज. हुआ? हो गया? क्या किया बताओ? See, it's given as AA dash is equal to A dash A. ठीक है? And B is given as A inverse A dash. ठीक है? You have to prove the value of BB dash is equal to I. Now, if B is equal to A inverse A dash, that means AB is equal to what? ये तो हमारे पास given conditions है. By pre-multiplying with A, you will get AB is equal to what? A dash, है ना. तो AB की जो वैल्यू आ गई that is equal to A dash. Now, BB dash की वैल्यू में प्रूव करनी है. Now, to find BB dash, use this. What is ABB dash is equal to? बताओ. What is AB? You know the property, it is commutative, associative, this thing. कि product of the multiplication of three matrices AB into C is same as A into BC, है ना. सब पता है आपको ये बात? तो वही मैंने यूज किया कि यहां पे मैंने प्री मल्टीप्लाइंग विद A, तो यहां पे AB into B. What is AB? AB is A dash. तो A dash B dash that is equal to BA का ट्रांसपोज. नाउ व्हाट इज B इक्वल्स टू? B किसके बराबर है? A इनवर्स A डैश. तो A इनवर्स A डैश A का होल डैश इज इक्वल टू, अच्छा A इनवर्स A डैश A किसके इक्वल है? A डैश इज इक्वल टू A डैश. तो यहां पे अगर मैं इसको कन्वर्ट करूं A डैश में, व्हाट इज दिस? सेम प्रॉपर्टी, कम्यूटेटिव एसोसिएटिव वाली प्रॉपर्टी दोनों. ए इनवर्स इंटू ए क्या मिलेगा? आई. दैट मीन्स इट इज इक्वल टू ए. इन शॉर्ट फाइनली ए इंटू बीबी डैश, जिसको आप ऐसे लिख सकते हैं हम फॉर द सेम प्रॉपर्टी, ठीक है, इज इक्वल टू ए. ए इनवर्स ले लें, प्री मल्टीप्लाइंग विद ए इनवर्स, तो बीबी डैश किसके इक्वल आएगा? आई इक्वल आ जाएगा. आया समझ में? इफ ए बी इज इक्वल, सी ये दोनों दे रखे हैं, इसका तो यूज बाद में होगा. दिस द मेन इंपॉर्टेंट थिंग. बी इज इक्वल टू ए इनवर्स ए डैश. सो यहां से पता चला ए बी इज इक्वल टू ए डैश, ए बी की वैल्यू ए ट्रांसपोज के इक्वल आ गई. टू फाइंड बी बी डैश मैंने इसको ए से मल्टीप्लाई किया बिकॉज यहां पे ए बी आया ए डैश के इक्वल. सो ए बी इज इक्वल टू ए डैश बी डैश विच इज बी ए का ट्रांसपोज. बी को लिखा हमने ए इनवर्स ए डैश, इसको रिवर्स करके लिख दिया, सो ये ए बन गया. तो इफ दिस इज इक्वल टू ए, दैट मींस ऑब्वियसली बी बी डैश इज इक्वल टू आई. ठीक है. कोई और तरीके से किया आप लोगों ने? हाँ बताओ क्या है. यहां पे करते हैं, चलो अनदर मेथड देखते हैं क्या किया है. बताओ क्या किया. बीबी डैश लिखा, ये किया बीबी डैश, है ना, ये दूसरा मेथड है. बीबी डैश को आपने लिखा ए इनवर्स ए डैश इंटू ए इनवर्स ए डैश का होल ट्रांसपोज, है ना, ये लिखा. आगे इसमें प्रॉपर्टी यूज करी की, क्या आएगा बताओ? ए इनवर्स ए डैश इंटू ए इनवर्स डैश. अब इसको लिख लिया ए डैश, ए इनवर्स ए डैश. एक सेम प्रॉपर्टी की ब्रैकेट्स तो कहीं भी लग सकते हैं. अगर चार भी ले लो ना आप, ए बी सी डी चार मैट्रिसेस हैं, तो आप ऐसे कहीं भी ब्रैकेट्स लगा सकते हो. इट इज सेम एज ए बी इंटू सी डी, कैसे भी लगा लो आप, सेम रहेगा. ठीक है. तो इसको लिखा हमने ए डैश. तो ए इनवर्स का होल डैश क्या होता है? ए डैश का इनवर्स. ये क्या बनेगा? दिस विल बिकम आई एंड दिस विल बिकम आई. ए डैश इंटू ए डैश का इनवर्स क्या बन जाएगा? आई बन जाएगा. तो आई इंटू आई, इट इज, ये ज्यादा छोटा मेथड है. ठीक है ना. तो आप क्वेश्चन को इस तरीके से भी कर सकते हो और इस तरीके से भी, जो हमारा जनरल मेथड है. ज्यादातर स्टूडेंट इस तरीके से फॉलो करेंगे ऑब्वियसली, बिकॉज यहाँ पे हम ये स्टेप जनरली इट्स वेरी ट्रिकी कि आप ए को उधर लेके जाओगे, फिर ए को प्री मल्टीप्लाई करोगे विद ए बी. ठीक है ना. सो ये प्रॉपर्टी, इसमें एक प्रॉपर्टी सबसे इंपॉर्टेंट यूज हो रही है. एक तो ये हो ही रही है ए डैश इज इक्वल टू ए डैश है, मतलब प्रॉपर्टी जब यहाँ पे यूज हो रही है, इट इज ए इनवर्स का ट्रांसपोज इज ट्रांसपोज का इनवर्स. ठीक है. So the transpose of the inverse of a matrix is equal to the inverse of its transpose. ठीक है. नेक्स्ट. हाँ जी. If alpha beta are the, let's say, real numbers which is not equal to 0 and f of n is a function which is equal to alpha n plus beta की power n, and this determinant just one second. The question is, see, यहाँ पे कर दो. The question is, if f of n is equal to alpha n plus beta n, ठीक है, एंड दिस डिटर्मिनेंट, राइट द क्वेश्चन, 1 प्लस f1, 1 प्लस f2, 1 प्लस f1, 1 प्लस f2, 1 प्लस f3, 1 प्लस f2, 1 प्लस f3 एंड 1 प्लस f4 इज इक्वल टू k टाइम्स, राइट, k टाइम्स 1 माइनस अल्फा होल स्क्वायर, 1 माइनस बीटा होल स्क्वायर इंटू अल्फा माइनस बीटा होल स्क्वायर. You have to find the value of k. You have to find the value of k, the numerical value of k. ठीक है. This is the question. If Fn is alpha n plus beta ki power n, and this determinant is equal to k times 1 minus alpha whole square, 1 minus beta whole square, and alpha minus beta whole square, you just have to find the value of k, the numerical value of k. K is a real number, alpha, beta are also non-zero real numbers. अगर आप पूरा इसको एक्सपैंड करोगे तो इट विल गेट लेंदी ना. जस्ट ट्राई टू ब्रेक इट. फर्स्ट सब्स्टिट्यूट द वैल्यू है ना, f1 f2 f3 and f4. Substitute the values and then try to break it. Use the hint is use the product of two determinants. Try to break it into as a product of two determinants. जो भी ये पूरा डिटरमिनेंट है इसको आप एज ए प्रोडक्ट ऑफ टू डिटरमिनेंट्स ब्रेक करने का ट्राई करो. ठीक है, बिकॉज अगर डायरेक्टली ओपन करोगे तो इट विल गेट वेरी लेंथी. थ्री को यू कैन राइट 1 + 1 + 1, क्योंकि इन बाकी ऑल द 8 एलिमेंट्स ऑफ द डिटरमिनेंट इट इज रिटन एज ए सम ऑफ 3 नंबर्स है ना, एनी 3 नंबर्स. दिस इज एक्चुअली दिस 3 1 + alpha + beta 1 + alpha square + beta square 1 + alpha + beta 1 + alpha square + beta square 1 + alpha cube + beta cube and 1 + alpha square + beta square 1 + alpha cube + beta cube and 1 + alpha 4 + beta 4. So you can write 3 as 1 + 1 + 1. Now try to break into product of two determinants. बताओ कौन कौन से डिटरमिनेंट्स होंगे जो इसको प्रोडक्ट की तरह ब्रेक होंगे. This was the question asked in last year IIT JEE Mains 2014. कैसे ब्रेक होगा? देखो ऐसे होगा ब्रेक. 1 alpha 1 1 1 1 alpha alpha square 1 beta beta square. ठीक है, इस तरीके से ब्रेक करो ताकि द सम विल कम 1 + 1 + 1. 1 × 1 + 1 × 1 + 1 × 1 है ना, पहला आ गया है उसमें. फिर 1 × ये वाले के लिए 1 × अल्फा, ठीक है, ऐसे ही आएगा ना, सॉरी यहां पे फिर क्या आएगा, अल्फा. इस तरीके से ट्राई टू ब्रेक इट. ठीक है, 1 + अल्फा, 1 × अल्फा प्लस देन 1 × 1, सॉरी यहां तो 1 × 1 ही आएगा ना, 1 × 1 + 1 × अल्फा प्लस 1 × बीटा. ठीक है, फिर लास्ट वाले में 1 × 1 + 1 × अल्फा स्क्वायर एंड देन 1 × बीटा स्क्वायर. आई थिंक दिस इज डन. ठीक है, फिर 1 × 1 + अल्फा × 1 + बीटा × 1, then 1 × 1 1 × alpha square plus beta square, then 1 + alpha cube plus beta cube, then 1 + alpha square plus beta. ये बन गया. This is the final expression to write this whole determinant as a product of two determinants. Now tell me, क्या ये दोनों सेम है? दोनों determinants ये दोनों सेम है, because rows and columns को if you interchange the rows and columns, the value of the determinant will become same, will remain same. So 1 बीटा एंड बीटा स्क्वायर का होल स्क्वायर हो गया ये, राइट. अब बस अब इसको एक्सपैंड करो, नहीं तो फिर इसको रो एंड तो वो एक्सप्रेशन लगा के रो एंड कॉलम ऑपरेशंस. सो ट्राई टू फाइंड आउट. ये समझ में आया? पहले बताओ डिटरमिनेंट को लिखना. ठीक है, देखो सी द एक्सप्रेशन इज सिमेट्रिक. यहाँ पे अल्फा स्क्वायर से खत्म हो रहा है, फिर अल्फा बीटा अल्फा स्क्वायर अल्फा क्यूब प्लस बीटा क्यूब, फिर अल्फा क्यूब से स्क्वायर से बीटा क्यूब एंड अल्फा की पावर 4 बीटा की पावर 4. इस तरह के एक्सप्रेशंस में यू कैन इसको ब्रेक कर सकते हो. यू कैन ब्रेक द डिटरमिनेंट इनटू टू प्रोडक्ट इनटू एज ए प्रोडक्ट ऑफ टू डिटरमिनेंट्स. तो यहाँ पे 1 अल्फा अल्फा स्क्वायर 1 बीटा बीटा स्क्वायर. अब होगा कैसे ब्रेक कि जो रोज में आ रहे हैं दैट विल बिकम कॉलम्स. जो रो में आ रहे हैं 1 1 1 1 अल्फा बीटा 1 अल्फा स्क्वायर बीटा से वो कॉलम्स बन जाएंगे 1 अल्फा बीटा दिस. सो इस ये इसका स्क्वायर हो गया. नाउ इफ यू अप्लाई द रो एंड कॉलम ऑपरेशंस you will get this 1 0 0 1 अगला अल्फा -1 अल्फा स्क्वायर -1, नेक्स्ट 1 बीटा -1 एंड बीटा स्क्वायर -1. इसका होल स्क्वायर चाहिए. सो फाइनल आंसर इज अल्फा -1 का होल स्क्वायर, बीटा +1 का होल स्क्वायर, बीटा -1 होल स्क्वायर माइनस बीटा -1 होल स्क्वायर, अल्फा +1 होल स्क्वायर एंड अल्फा -1 होल स्क्वायर. सही है. इफ यू क्रॉस मल्टीप्लाई, ये पूरे का स्क्वायर हो गया ना पूरे का. सो क्रॉस मल्टीप्लाई करिए किया हमने, अल्फा -1 होल स्क्वायर इंटू बीटा +1 इंटू बीटा -1 का होल स्क्वायर माइनस बीटा -1 होल स्क्वायर इंटू अल्फा +1 होल स्क्वायर अल्फा -1 होल स्क्वायर. द कॉमन पार्ट इज व्हाट? द कॉमन पार्ट इज अल्फा -1 होल स्क्वायर, बीटा -1 होल स्क्वायर. अच्छा इस पूरे का होल स्क्वायर, आई एम रियली सॉरी, ये तो पूरे का होल स्क्वायर होगा ना, सॉरी इस पूरे का होल स्क्वायर, सॉरी. ठीक है, दिस इज इस पूरे का होल स्क्वायर बिकॉज डिटरमिनेंट में पूरे का होल स्क्वायर है. सो डिटरमिनेंट इज अल्फा -1 बीटा +1 बीटा -1 माइनस बीटा -1 अल्फा +1 अल्फा -1. इस पूरे का होल स्क्वायर हो जाएगा एंड द कॉमन टर्म इज अल्फा -1 एंड बीटा -1, वो बाहर आ जाएंगे एंड अंदर इज अल्फा माइनस बीटा का होल स्क्वायर. ठीक है, so the answer is for k the value is 1. This is true for 1. ठीक है, understood the problem कि आपको you have to break this determinant as a product of two determinants. After that it will become same and it will become the determinant of this square of the determinant. Now apply the row and column operations, make these two elements as 0. So now open the determinant as whole square, so it will become this and k will be equal to 1. ठीक है, next. So that was question of determinant. This is a question of matrices. If P is equal to 1 1 2 and alpha 3 4 3 3 4, is the adjoint of a 3 by 3 matrix and determinant A is equal to 4, you have to find the value of alpha. ये जो matrix है P is the adjoint of some matrix 3 by 3 matrix, ठीक है A. ये जो A दिया हुआ है it's the adjoint of a 3 by 3 matrix A and determinant of that matrix is 4. So आपको you need to find the value of alpha. So a matrix is given and it's an adjoint of a 3 by 3 matrix A and the determinant of matrix A is 4. So find the value of alpha. Hint is that you have to apply the relation between the determinant of a matrix and its determinant of its adjoint. What is the relation between the determinant of a matrix and the adjoint determinant of its adjoint? क्या रिलेशन होता है? P को you can write adjoint of A है ना? P is equal to adjoint A. So if determinant of A is 4, then what is the determinant of adjoint A? This is the hint, this is the application. हो गया? देखो P is actually adjoint of A है ना, right? P तो adjoint हो गया, A हो गया and determinant given is A का जो determinant given is 4. अच्छा tell me adjoint A का determinant, what is adjoint of determinant in form of determinant of A? What is the formula? A की power mod A की power n minus 1 where n is the order of the matrix. Now tell me what is the order of this matrix? 3 by 3. So adjoint A का जो determinant आएगा वो कितना आएगा? 4 का square because determinant A is 4 and n minus 1, 3 minus 1 is 2, so is equal to 16. So adjoint A is basically P है ना? So P का determinant is 16. You can easily find out alpha, the value of alpha. Determinant of P बताओ. 1 into 12 minus 12 minus alpha times 4 minus 6 plus 3 times 4 minus 6 must be equal to 16. So that means ये तो 0 हो गया. यहाँ से कितना आएगा? 2 alpha and this is equal to 22. So alpha is equal to 11. So for the value of alpha is equal to 11, the determinant of A is equal to 4 and P is the adjoint of matrix A. ठीक है? So this is simple formula. Adjoint A का जो mod होता है, the determinant is determinant of A की power n minus 1 for nth order. So mod A is given 4, so it is 16. So adjoint the determinant of P is 16. So you can find the determinant of P and find the value of alpha. Next. This is another question for system of equations. ठीक है, related to both the chapters, matrices as well as determinants. So you have to find the number of values of k for which number of values of k or value of k basically for which the system of equations has no solution. For which the system of equations has no solution. k की जितने भी values हैं, just also find number of values and you can find the value also. ठीक है? Do it by any method. You can either use the matrix method or you can use the Cramer's rule and determinant. No solution का मतलब A into adjoint A into B must be equal to non-zero. The system must have no solution. That means determinant must be 0 and the numerator, which is adjoint A into B, is not equal to 0. That means null matrix. Or you can use the Cramer's rule. Cramer's rule says that delta, that means determinant, must be 0, and out of delta 1, delta 2 and delta 3, at least one must be non-zero. You can use a shortcut also, है ना? थोड़ा सा सोचो, think about it. ये क्वेश्चन ऐसे ही हो जाएगा, देखे. For what values of k the system of equation has no solution? ऐसे क्वेश्चंस में जनरली यूज क्रैमर्स रूल. ठीक है, डिटरमिनेंट में मत जाओ बिकॉज इट विल कंज्यूम योर टाइम. सो क्रैमर्स रूल थोड़ा इजी होता है बिकॉज डिटरमिनेंट फाइंड करना इजी होता है rather than finding the adjoint of a matrix then multiplying the matrix. So use क्रैमर्स रूल. पता ना क्या होता है क्रैमर्स रूल? देखो मैं बता देता हूँ व्हाट इज क्रैमर्स रूल. क्रैमर्स रूल इज कि if there are three equations a1x plus b1y plus c1z is equal to d1, likewise a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. So delta को मैं बोलूंगा, delta is simply the coefficients of x, a1 a2 a3 in the first column, coefficient of y in the second column and coefficient of z in the third column. This is delta. delta 1 में हम लोग क्या करेंगे, जो राइट वाला पार्ट है d1 d2 d3 उसको फर्स्ट कॉलम से रिप्लेस कर देंगे. That is d1 d2 d3 and these two columns will be same, है ना, this remains same. डेल्टा 2 में क्या करेंगे, ये जो राइट वाले पार्ट्स हैं इसको सेकंड कॉलम में रिप्लेस करेंगे. विल रिप्लेस द सेकंड कॉलम बाय d1 d2 d3, रिमेनिंग फर्स्ट एंड थर्ड सेम. a1 a2 a3 d1 d2 d3 एंड c1 c2 c3 विद रिस्पेक्ट टू डेल्टा. डेल्टा में चेंजेस कर रहे हैं हम लोग, ठीक है. डेल्टा इज दिस, फर्स्ट कॉलम को राइट वाले पार्ट से रिप्लेस करेंगे तो डेल्टा 1, सेकंड कॉलम को रिप्लेस करेंगे इट इज डेल्टा 2, एंड थर्ड को इफ यू रिप्लेस द थर्ड कॉलम बाय d1 d2 d3 इट विल बिकम डेल्टा 3. सो डेल्टा 3 जो हो जाएगा वो लास्ट वाला कॉलम होगा, a1 a2 a3 b1 b2 b3 एंड d1 d2 d3. नाउ सी, नाउ x इज, देखो x जो होगा वो क्या होगा, डेल्टा 1 अपॉन डेल्टा, y will become delta 2 by delta and z will become delta 3 by delta. ये आंसर्स हो गए. Now obviously you will get a unique solution, you will get a unique solution if delta is not equal to 0. delta 1 delta 2 delta 3 में कुछ भी हो सकता है, belongs to real number, but delta must be non-zero for unique solution. तो आपके x y z आ जाएंगे. But if you want no solution, that means infinity चाहिए आपको, that means delta तो 0 होना ही होना चाहिए, 0, but नो सॉल्यूशन के साथ साथ एटलीस्ट वन ऑफ डेल्टा 1 डेल्टा 2 डेल्टा 3 मस्ट बी कितना होना चाहिए, नॉन जीरो होना चाहिए. एक तो नॉन जीरो होना चाहिए ऊपर न्यूमरेटर में. देखो तीनों तो जीरो होंगे, नीचे ऊपर कम से कम एक नॉन जीरो बन जाए, एक नॉन जीरो, तो आपका आंसर इन्फिनिटी होगा ना, 2/0. हाँ, तो नो सॉल्यूशन फॉर्म हो जाएगा. एंड फॉर इनफाइनाइट 0/0 फॉर्म, दैट मींस इनफाइनाइट के लिए डेल्टा 1 डेल्टा 2 डेल्टा 3 सारे सबके सबकी वैल्यू क्या होनी चाहिए, 0. ये 0 होना चाहिए. सो दिस इज नोन एज क्रैमर्स रूल. तो इस क्वेश्चन में वी विल यूज द क्रैमर्स रूल. फर्स्ट वी विल फाइंड द डिटरमिनेंट मस्ट बी 0. उसके बाद वी विल सी कि एटलीस्ट एक तो क्या होना चाहिए, नॉन जीरो होना चाहिए, एटलीस्ट वन आउट ऑफ डेल्टा 1 डेल्टा 2 एंड डेल्टा 3. ठीक है, चलो लेट्स स्टार्ट. हो गया ये सबका, अंडरस्टूड दिस, ठीक है, लिख लिया सबने. सो लेट्स स्टार्ट विद द क्रैमर्स रूल एप्लीकेशन ऑन दिस क्वेश्चन. अच्छा, व्हाट इज डेल्टा, चलो बताओ डेल्टा क्या होगा इस केस में. डेल्टा विल बी 2 1 1 -1 -2 1 2 1 k must be equal to 0. k कितना आ रहा है, 1. बताओ 2 के साथ क्या आएगा, -2k -1 +1 के साथ आएगा k -1 और +2 के साथ आएगा 1 + 2 that is equal to 0. -4k -2 plus k -1 plus 6 is equal to 0. This becomes -3k and this is equal to कितना, is equal to 3. 3 आ रहा ना, -3. ठीक है, तो k is equal to 1. So k की वैल्यू 1 के लिए it will become no solution. बट अभी सिर्फ डेल्टा 0 है, डेल्टा 0 इनफाइनाइट के केस में भी हो सकता है ना. डेल्टा जो 0 है वो इनफाइनाइट केसेस के केस में भी हो सकता है. तो हमें वी विल मेक श्योर कि एटलीस्ट 1 मस्ट बी नॉन जीरो. लेट्स फाइंड आउट डेल्टा 1. चलो डेल्टा 1 बताओ क्या होगा, टेल मी. लेट्स से कि क्या क्या नॉन जीरो हो सकता है, क्योंकि k इज इक्वल टू 1 के लिए तो इनफाइनाइट सॉल्यूशंस भी आ सकते हैं, ठीक है ना. नो सॉल्यूशन के लिए देखते हैं क्या आता है. डेल्टा 1 में विल रिप्लेस द फर्स्ट कॉलम बाय द d1 d2 d3. दैट मींस 2 -4 4, बाकी वही रहेंगे, -1 -2 1 एंड 2 1 k, है ना, इज नॉट इक्वल टू 0. चलो बताओ यहां से क्या आ रहा है, -2k -1 +1 के साथ -4k -4 और 2 के साथ -4 + 8 इज नॉट इक्वल टू 0. इट मींस -4k -2 -4k -4, ये हो जाए कितना, 8 इज नॉट इक्वल टू 0. यहां से आपका आ गया -8k और ये कितना होगा, +2 इज नॉट इक्वल टू 0. सो k मस्ट नॉट बी इक्वल टू 1/4. ठीक है ना. देखो थर्ड करने की तो जरूरत नहीं है, थर्ड वाले में तो वैसे भी यहां पे आएगा 2 4 एंड -4. इट मींस 2 4 एंड -4 का क्या आएगा आंसर, 1 2 एंड -2, तो वो तो उसमें तो के निकलेगा भी नहीं वैसे भी कुछ, ठीक है, क्योंकि एटलीस्ट वन मस्ट बी नॉन जीरो। तो एटलीस्ट वन बोला है मैंने, तीनों भी नॉन जीरो हो सकते हैं, ठीक है, तो ये नॉन जीरो हो सकता है एटलीस्ट वन। सो के इज नॉट इक्वल टू 1/4 अगर ये नॉन जीरो हो जाता है तो। दूसरे वाला क्या आएगा बताओ, डेल्टा टू से क्या आ रहा है? डेल्टा टू निकाल के देखो, डेल्टा टू से क्या आएगा, क्योंकि के अगर 1/4 हो गया तो इट विल बिकम जीरो, डेल्टा वन जीरो बन जाएगा अगर के 1/4 हो गया तो। डेल्टा टू बताओ क्या आएगा, के की वैल्यू 1 आएगी, ठीक है, और डेल्टा थ्री कैसा आएगा चेक करो, व्हाट इज डेल्टा थ्री, जीरो और नॉन जीरो। भाई डेल्टा वन जीरो तो हो सकता है वैसे भी, डेल्टा वन जीरो इट माइट बी पॉसिबल, क्योंकि एटलीस्ट वन बोला है ना उसने, कोई एक नॉन जीरो होना चाहिए बस, ठीक है। डेल्टा वन अगर नॉन जीरो है, लेट्स सी अगर जीरो पे हुआ तो के कैन बी इक्वल टू 1/4। अभी देखते हैं क्या होगा। डेल्टा टू आपने क्या बोला, व्हाट इज डेल्टा टू, डेल्टा टू जीरो करने पर के कितना आ रहा है, 1 आ रहा है, और डेल्टा थ्री कैसा आ रहा है, नॉन जीरो आ रहा है। इसका मतलब हर वैल्यू के लिए दे विल बिकम नो सॉल्यूशन, क्योंकि एटलीस्ट एक तो होना चाहिए नॉन जीरो, इसका मतलब सबके लिए नो सॉल्यूशन आ रहा है। आया बात समझ में? सी, अगर आपको इनफाइनाइट सॉल्यूशंस दिया होता तो के वन भी होता, के 1/4 भी होता, दूसरे से भी के कुछ आता, तीसरे से भी के कुछ आता, तो सब जीरो होते, सबके लिए इनफाइनाइट सॉल्यूशंस आते। नो सॉल्यूशन के लिए डेल्टा जीरो होना चाहिए डेफिनेटली, के वन आ गया। डेल्टा वन जो है वो क्या होना चाहिए, एटलीस्ट एक नॉन जीरो होना चाहिए, तो एटलीस्ट एक नॉन जीरो वो हमारा आ रहा है ऑलरेडी। इसका मतलब दिस सिस्टम ऑफ इक्वेशन हैज नो सॉल्यूशन फॉर दीज वैल्यूज ऑफ के, जो आ रही है हमारे पास, ठीक है ना। आया ये पार्ट समझ में आपको? क्योंकि डेल्टा जीरो तो डेफिनेटली है, इट इज मस्ट, के इज इक्वल टू वन तो मस्ट है, तो वो तो डेल्टा टू से भी आ गया, वो जीरो होगा ही होगा डेफिनेटली, क्योंकि के वन आ रहा है, तो के वन तो आना ही चाहिए वैसे भी। दूसरा, डेल्टा थ्री नॉन जीरो आ गया, तो डेल्टा थ्री नॉन जीरो आ गया, दैट मींस द सिस्टम ऑफ इक्वेशंस हैज नो सॉल्यूशन फॉर ईच एंड एवरी वैल्यू ऑफ के, चाहे डेल्टा वन जीरो से भी आ जाए, तो 1/4 के लिए, वन के लिए, इन दोनों वैल्यूज के लिए हैज नो सॉल्यूशन। अब मैं जब कुछ शॉर्टकट की बात कर रहा था, वो ऐसे कर रहा था, मुझे कैसे पता चला के की वैल्यू वन आएगी, अगर आप ध्यान से देखो इन तीनों एग्जांपल्स को, ठीक है, देखो देखो इधर देखो, ये है 2x माइनस वाई प्लस 2z इज इक्वल टू 2, x माइनस 2y प्लस z इज इक्वल टू -4, और x प्लस वाई प्लस के जेड इज इक्वल टू 4। अब ध्यान से देखना कैसे पता चला k की वैल्यू 1 आएगी। इफ आई सब्ट्रैक्ट दीज टू इक्वेशंस, अगर मैं दोनों को सब्ट्रैक्ट कर दूं, फर्स्ट और सेकंड को, सो यू विल गेट x प्लस वाई प्लस जेड इज इक्वल टू, सब्ट्रैक्ट करने पर कितना आ रहा है 6, और इधर आ रहा है x प्लस वाई प्लस के जेड इज इक्वल टू 4। तो अगर k की वैल्यू में को मैं 1 रख दूं अगर, तो ऑब्वियसली 6 कैन नॉट बी इक्वल टू 4। यहां से मुझे पता चला शॉर्टकट से कि k की वैल्यू 1 नहीं हो सकती। तो इस तरीके से भी यू कैन वर्क आउट ऑन दीज थिंग्स, कि आप देखना कि नो सॉल्यूशन का मतलब देखो ऐसे होता है नो सॉल्यूशन। इफ से x दो वेरिएबल में देखते हैं, x प्लस वाई इज इक्वल टू 5 और 2x प्लस 2y इज इक्वल टू लेट्स से 7, तो आप देख सकते हो कि x प्लस वाई जो आ रहा है वो 7/2 आ रहा है, तो ऑब्वियसली दोनों 5 और 7/2 बराबर तो हो नहीं सकते। इसका मतलब है क्या, नो सॉल्यूशन, दे विल नेवर इंटरसेक्ट, ठीक है। और इनफाइनाइट सॉल्यूशन तब होते हैं जब दोनों लाइन सेम होती है, आइडेंटिकल होती है, तो वो इनफाइनाइट सॉल्यूशन होते हैं, ठीक है ना। थोड़ा इस तरीके से आप, अगर आप इफ यू सब्ट्रैक्ट दीज टू इक्वेशंस, तो आप देखोगे कि तीसरी इक्वेशन मिलेगी आपको, अगर k को 1 डालोगे तो 4 कैन नॉट बी इक्वल टू 6, तो k की वैल्यू कैन नॉट बी 1, ठीक है। अगर k 1 हो गया तो नो सॉल्यूशन आ जाएगा, तो वहां से पता चल जाएगा, रेदर देन आप इस तरह लेंदी करो, टाइम कंज्यूम। तो दिस इज शॉर्टकट टू डू दिस क्वेश्चन। नहीं तो ऑप्शंस में होंगे, यू कैन पुट इन द ऑप्शन से वैल्यू आप उतार के देख सकते हो किस किस में वैल्यूज आ रही हैं। ठीक है, नेक्स्ट. Another question of determinant. Let omega be the complex number, the complex cube root of unity. Cos 2 pi by 3 plus iota sin 2 pi by 3. Find the number of distinct complex numbers z satisfying this determinant is equal to 0. ठीक है, ओमेगा विद द कॉम्प्लेक्स नंबर cos 2 pi by 3 plus iota sin 2 pi by 3. It's a cube root of unity. You have to find the number of distinct complex numbers z which is satisfying this determinant is equal to 0. How many complex numbers will satisfy this? Solve this determinant and find कि कितनी values of z will satisfy this. ठीक है, omega is the cube root of unity. You can use the row operations and column operations as well. ठीक है ना, you can apply C1 is to C1 plus C2 plus C3 so that 1 plus omega square will become 0. See, z plus 1 omega and omega square, omega z plus omega square 1, omega square 1 and z plus omega is equal to 0. So you can apply the column operation which is C1 is tending to C1 plus C2 plus C3. Okay, you can interchange C1 with C1 plus C2 plus C3. So what it will become? Z plus 1 plus omega square, then omega and omega square. This will also become z plus 1 plus omega square, z plus omega square and 1, and this will also become z plus omega square plus 1 and z plus omega is equal to 0. ठीक है? So what is 1 plus omega square? 0. So answer is z and z, omega square, z plus omega square 1 and z plus omega is equal to 0. So we'll take z common. So the determinant will become 1 1 1, है ना? अंदर क्या बचेगा? ओमेगा प्लस, अच्छा अभी भी कर सकते हैं हम, है ना, दोबारा नहीं, बट कोई फायदा नहीं चला एनीवेज, ओमेगा z प्लस ओमेगा स्क्वायर 1, ओमेगा स्क्वायर 1 एंड z प्लस ओमेगा. अब इन दोनों को जीरो बना देते हैं. सो इनको जीरो बनाएंगे तो 1 0 0, दिस विल बिकम ओमेगा z प्लस ओमेगा स्क्वायर माइनस ओमेगा 1 माइनस ओमेगा. ठीक है, और यहां से आएगा ओमेगा स्क्वायर 1 माइनस ओमेगा स्क्वायर एंड z प्लस ओमेगा माइनस ओमेगा स्क्वायर इज इक्वल टू 0. अच्छा, एक z भी था यहां पे, है ना, तो एक डिटरमिनेंट तो एक तो आ गया 0. ठीक है ना, एक तो 0 बन ही गया. अच्छा, हम और रिड्यूस कर सकते हैं इसको, C3 को इंटरचेंज करते हैं विद C1 प्लस C2 प्लस C3, उससे होगा कुछ? ज्यादा फायदा नहीं होगा ना. बस ये वाला पार्ट, दिस विल बिकम 0, ये वाला पार्ट 0 बन जाएगा. अब बताओ कितनी वैल्यूज और आ रही हैं z की? एक तो आई गई 0, उसके अलावा बताओ कितनी आ रही है? टेल मी द वैल्यूज ऑफ z नाउ. अब बस क्रॉस मल्टीप्लाई करना है बस आपको. लेट्स क्रॉस मल्टीप्लाई द क्वेश्चन. ठीक है, ये जो आपका फाइनल आंसर आया है इसको क्रॉस मल्टीप्लाई करते हैं. इतना पार्ट क्लियर है सबको? ठीक है, फर्स्ट C1 को इंटरचेंज करेंगे C1 प्लस C2 प्लस C3 से, उसके बाद फाइनली z कॉमन आएगा तो 1 1, तो z तो एक तो कॉम्प्लेक्स नंबर 0 ही आ गया, दूसरा 1 1 1, इसको 0 0 बनाया. नाउ क्रॉस मल्टीप्लाई द क्वेश्चन. सी z प्लस ओमेगा स्क्वायर माइनस ओमेगा इंटू z प्लस ओमेगा माइनस ओमेगा स्क्वायर, यही है. एंड फाइनल इज 1 माइनस ओमेगा स्क्वायर इंटू 1 माइनस ओमेगा इज इक्वल टू 0. एक तो z 0 आ गया, एक तो 1 आ गया. इसको सॉल्व करेंगे तो फाइनल आंसर विल बिकम z का स्क्वायर माइनस, इसको हम ऐसे लिख सकते हैं ना, माइनस, यहां पे था आपका z प्लस था ना, z प्लस ओमेगा स्क्वायर माइनस ओमेगा, तो ये हो जाएगा आपका z स्क्वायर प्लस z ओमेगा माइनस z ओमेगा स्क्वायर प्लस z ओमेगा स्क्वायर प्लस ओमेगा क्यूब विल बी 1 माइनस ओमेगा 4 विल बी ओमेगा, और लास्ट में माइनस z ओमेगा माइनस ओमेगा स्क्वायर और प्लस 1 इज इक्वल टू 1 माइनस ओमेगा स्क्वायर प्लस 1, यही आएगा. सो यहां से आपका जो आंसर आ रहा है 1 तो कैंसिल आउट हो गए. ठीक है, z ओमेगा स्क्वायर कैंसिल आउट हो गया, और कुछ हुआ कैंसिल? z ओमेगा z स्क्वायर माइनस w स्क्वायर इज इक्वल टू कितना? यहां से माइनस w माइनस ओमेगा स्क्वायर आ रहा है. ठीक है, ये भी कैंसिल आउट हो गया. z स्क्वायर इज इक्वल टू माइनस ओमेगा. कितनी वैल्यूज आ रही हैं? दो वैल्यूज यहां से आ जाएंगी क्योंकि कॉम्प्लेक्स नंबर्स चाहिए आपको, है ना. सो टोटल हाउ मेनी वैल्यूज? 3 वैल्यूज. एक तो 0 आ गया, प्लस माइनस ओमेगा का जो स्क्वायर रूट होंगे उसकी 2 वैल्यूज आएंगी. सो टोटल वैल्यूज इज इक्वल टू 3. ठीक है, सिंपल क्वेश्चन है. फर्स्ट तो C1 को चेंज करोगे विद C1 प्लस C2 प्लस C3 तो z बन जाएंगे. z विल कम आउट कॉमन 1 1 1, ये बन जाएगा. इसको 0 0 सॉल्व करोगे एंड क्रॉस मल्टीप्लाई इट, तो यहां से आपकी ये वैल्यूज बचेंगी सिर्फ. ठीक है ना. सो टोटल 3 वैल्यूज ऑफ द कॉम्प्लेक्स नंबर. नेक्स्ट, another question of matrix. let m and n be 2 3 into 3 non-singular skew symmetric matrices such that mn is equal to nm. If pt denotes the transpose of p, prove that m square n square into m transpose n का whole inverse into mn inverse का whole transpose is equal to minus m square. ठीक है ना? इसमें आपको you have to use the properties of transpose and inverse. जो भी प्रॉपर्टीज है उससे प्रूफ करना है कि इसकी जो वैल्यू है वो माइनस एम स्क्वायर के बराबर आएगी. एक चीज मैं आपको बताता हूं, लेट मी टेल यू. इसमें लिखा हुआ है क्वेश्चन में 3 into 3 नॉन सिंगुलर स्क्यू सिमेट्रिक. इट्स अ हाइपोथेटिकल सिचुएशन. 3/3 स्क्यू सिमेट्रिक मैट्रिक्स का डिटरमिनेंट इज ऑलवेज 0. ठीक है, आई रिपीट, द डिटरमिनेंट ऑफ ए 3/3 या ऑड ऑर्डर skew symmetric matrix is always 0. So it's a hypothetical situation कि where it is given that 3/3 non-singular skew symmetric matrices. उसका एक रीजन है क्योंकि here जो हमने इनवर्स लिखा है वो m का इनवर्स भी लिखा है. अब सुनो, m and n जो है उनका इनवर्स, अब जो क्वेश्चन में इनवर्स दिया हुआ है, that means इनवर्स क्या होना चाहिए, एग्जिस्ट करना चाहिए. बट अगर m and n skew symmetric matrix से ऑड ऑर्डर के, उनका डिटरमिनेंट होगा 0. if the determinant is 0, that inverse does not exist. So क्वेश्चन में इनवर्स एग्जिस्ट कराना जरूरी है. That's why we have taken the hypothetical situation because of the question belongs to the properties of the determinant. तो इसमें ऐसा कुछ भी नहीं है, इसमें कोई और प्रॉपर्टी यूज होगी. So प्रॉपर्टी को यूज करने के लिए हमने ऐसे मान लिया कि there has to be a matrix which is non-singular and skew symmetric 3/3 matrix. ठीक है, so इसको कंफ्यूज करने की जरूरत नहीं है आपको, बस इनवर्स को एग्जिस्ट कराने के लिए ही. That's why it is given non-singular. ठीक है ना? बट इसमें सिर्फ जो एप्लीकेशन है, डेट इज ओनली फॉर दिस इनवर्स एंड ट्रांसपोज. बस इसमें एडजॉइंट वाली ऐसी कोई प्रॉपर्टी नहीं है. जस्ट यूज द प्रॉपर्टीज ऑफ इनवर्स एंड ट्रांसपोज. है ना? इनवर्स की प्रॉपर्टी अप्लाई करो. ए बी का होल इनवर्स इज बी इनवर्स ए इनवर्स, है ना? और मैंने पहले बताया द प्रोडक्ट ऑफ ऑल द मैट्रिसेस इज कम्यूटेटिव एज वेल एज एसोसिएटिव. सो ब्रैकेट्स जो है वो कहीं भी आप लगा सकते हो. एंड ऑल्सो गिवन mn इज इक्वल टू nm. ये भी ध्यान रखना, mn की वैल्यू nm के इक्वल भी दे रखी है. एंड यू कैन ब्रेक m स्क्वायर n स्क्वायर एज mm इंटू nn. ऐसे ब्रेक कर सकते हो. ठीक है, m स्क्वायर n स्क्वायर को यू कैन राइट m इंटू m एंड n इंटू n. ये भी एक हिंट है. m स्क्वायर n स्क्वायर को यू कैन नॉट राइट mn का होल स्क्वायर. ठीक है, होल स्क्वायर कुछ नहीं होता है. You can write it like this, है ना? m स्क्वायर n स्क्वायर. अच्छा, व्हाट इज द इनवर्स? इनवर्स का क्या फॉर्मूला होता है? n इनवर्स एंड m ट्रांसपोज का इनवर्स, है ना? खोल दिया इसको मैंने, ओपन कर दिया. और ट्रांसपोज का क्या फॉर्मूला होता है? जो राइट वाला जो है mn इनवर्स का ट्रांसपोज, इट इज n इनवर्स का ट्रांसपोज इनटू m ट्रांसपोज. ये भी ध्यान रखना कि इट्स ए स्क्यू सिमेट्रिक मैट्रिक्स। स्क्यू सिमेट्रिक मैट्रिक्स का मतलब m ट्रांसपोज इज इक्वल टू माइनस m एंड n ट्रांसपोज इज इक्वल टू माइनस n फॉर स्क्यू सिमेट्रिक। ये मालूम है ना आपको? व्हाट इज स्क्यू सिमेट्रिक एंड सिमेट्रिक? सॉरी, स्क्यू सिमेट्रिक, m इज इक्वल टू माइनस m डैश और ट्रांसपोज एंड n इज ऑल्सो माइनस n ऑफ ट्रांसपोज। ये स्क्यू सिमेट्रिक मैट्रिक्स की प्रॉपर्टी होती है। नाउ लेट्स ओपन दिस, है ना? इसको ओपन करते हैं। चलो, m स्क्वायर n स्क्वायर को देखो इधर, mm इंटू n इंटू n इनवर्स। आप किसी को भी मल्टीप्लाई कर सकते हो, बार बार बोल रहा हूं मैं ये चीज, ठीक है? इंटू दिस इज व्हाट? अच्छा, व्हाट इज m ट्रांसपोज? बोलो, m ट्रांसपोज को क्या लिख सकते हैं? माइनस m। सो माइनस m, अच्छा माइनस बाहर ले लें, इट्स स्केलर क्वांटिटी, सो इसका m डैश आ गया यहां पे। ठीक है, समझ में आ रहा है सबको? m डैश लिख लिया मैंने इसको। m ट्रांसपोज इज माइनस m, माइनस बाहर चला गया, सो इसका m डैश, सॉरी m इनवर्स, m इनवर्स। यहां तक क्लियर हुआ? बताओ, m इनवर्स हो गया यहां से? ठीक है। अच्छा, व्हाट इज n इनवर्स? इसको भी उल्टा लिख सकते हैं। n इनवर्स को यू कैन राइट इट एज n ट्रांसपोज का इनवर्स एंड दिस इज m ट्रांसपोज। सो मैं अगर मैं दोबारा सॉल्व करूं, अच्छा बताओ, व्हाट इज n इंटू n इनवर्स? I। सो आंसर इज माइनस m स्क्वायर, ठीक है, n इंटू m इनवर्स, ठीक है, इसको m इंटू m ही लिख लेते हैं, ठीक है, m इंटू m इंटू एन एम इनवर्स। अच्छा, इसको क्या लिखेंगे? nt को माइनस n, ये माइनस माइनस विल बिकम प्लस, ये क्या हो जाएगा फिर? n इनवर्स, और ये क्या बनेगा? m ट्रांसपोज, फिर से माइनस m, फिर से माइनस m। कैन यू टेल मी, आप mn को क्या लिख सकते हो? पता क्यों लिख रहा हूं मैं इनको nm? क्योंकि फिर mm इनवर्स विल बिकम i, ठीक है ना? तो माइनस m, इसको लिखेंगे nm, ये हो जाएगा m इनवर्स, n इनवर्स एंड व्हाट? m। बताओ क्या बनेगा ये? माइनस m इंटू n, व्हाट इज, अब इसको ब्रैकेट को मैं यहां लगा देता हूं, है ना? ब्रैकेट चेंज हो सकता है ऐसे। बताओ क्या आएगा? i n इनवर्स इंटू m। व्हाट इज n इनवर्स? i, दिस इज माइनस m स्क्वायर। ये क्वेश्चन था। द फुल यूज ऑफ द प्रॉपर्टीज, इसमें सीधा प्रॉपर्टी, मल्टीप्लीकेशन प्रॉपर्टी यूज हो रही है, ट्रांसपोज की प्रॉपर्टीज यूज हो रही है, इनवर्स की प्रॉपर्टीज यूज हो रही है, ठीक है? और स्क्यू सिमेट्रिक का जो फॉर्मूला होता है, स्क्यू सिमेट्रिक इज m ट्रांसपोज इज माइनस m। तो जहां जहां ट्रांसपोज था पहले, मैंने वहां माइनस m रखा, यहां भी माइनस m, और इसको मैंने उल्टा कर दिया ना, ट्रांसपोज को अंदर, इसको, ताकि इसको माइनस n रख दे वहां। तो तीन माइनस आ गए, दैट्स व्हाई एक माइनस रिटेन रहेगा, ठीक है? नाउ यहां पे m इंटू mn इंटू दिस विल बिकम i, सो m इनवर्स, दिस इज आपका n इनवर्स, दिस इज माइनस, माइनस तो बाहर चला गया, mn विल बिकम nm, दैट्स व्हाई इट विल बिकम i, ये वाला पार्ट है ना? So, ये वाला पार्ट मिलके क्या बन जाएगा? i, सो माइनस m स्क्वायर विल रिटेन। ठीक है ना? तो यूज ऑफ द ट्रांसपोज प्रॉपर्टी, इनवर्स प्रॉपर्टी, स्क्यू सिमेट्रिक प्रॉपर्टी एंड प्रोडक्ट प्रॉपर्टी ऑफ द मैट्रिसेस। ठीक है? नेक्स्ट, another question of the mathematical reasoning, find the negation of the statement। negation का मतलब वही जो आपका है ना, उल्टा, जस्ट रिवर्स। इफ आई बिकम ए टीचर देन आई विल ओपन ए स्कूल, इज टीचर लिखा हो, इफ आई बिकम ए टीचर देन आई विल ओपन ए स्कूल। इफ एंड देन, यानी कि कौन सा? सिंगल एरो वाला, है ना? इफ एंड देन वाला जो मैंने बताया था। अच्छा, लेट मी टेल यू करना कैसे है। सी, इफ आई बिकम ए टीचर, दैट मींस ये हो गया P, बिकमिंग ए टीचर, और Q हो गया आई विल ओपन ए स्कूल। ठीक है? तो बेसिकली पता है आपको ये निकालना है, P इंप्लाइज इफ एंड देन Q, इस पूरे का नेगेशन। ठीक है? नेगेशन ऑफ P इंप्लाइज Q। इफ आई बिकम ए टीचर देन आई विल ओपन द स्कूल, ये P और Q होगा, इसका नेगेशन बताना है आपको। ठीक है? This is the statement. Find the negation of the statement. ठीक है? So negation of P implies Q. हालांकि द क्वेश्चन विल हैव द ऑप्शंस, तो यू कैन चूज वन ऑप्शन, ठीक है. फर्स्ट मेक द ट्रुथ टेबल ऑफ नेगेशन ऑफ पी इंप्लाइज क्यू, ठीक है ना. उसके बाद जो ऑप्शंस होंगे उसके अकॉर्डिंगली वी विल डिसाइड दैट दिस इज इक्विवेलेंट टू विच स्टेटमेंट, है ना. इसका नेगेशन क्या स्टेटमेंट होगा. अच्छा, ट्रुथ टेबल में जस्ट ट्राई टू फाइंड आउट ये जो आपका नेगेशन ऑफ पी इंप्लाइज क्यू है, ठीक है, ये किस ट्रुथ टेबल के इक्वल होगा. जस्ट ट्राई टू फाइंड आउट. ये जो नेगेशन है, नेगेशन ऑफ P implies Q, यानी इफ आई बिकम ए टीचर देन आई विल ओपन द स्कूल, इस पूरे का जो नेगेशन होगा दिस इज इक्विवेलेंट टू विच पार्ट. उसका ट्रुथ, इसका जो ट्रुथ टेबल होगा वो किससे मैच करेगा, वही उसका आंसर होगा. अच्छा, एक बार इसका ट्रुथ टेबल बनाओ. चलो लेट्स मेक द ट्रुथ टेबल. बन गया? क्या बना बताओ. हालांकि विल हैव ऑप्शंस, तो इसलिए ज्यादा उसमें डरने वाली बात नहीं है. आई हैव नॉट गिवन द ऑप्शंस. ऑप्शंस आप देखोगे तो यू विल चेक, है ना. अच्छा, P ये है, Q ये है. सेम ट्रू 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 फॉल्स द ट्रुथ टेबल वैल्यूज, ठीक है. P इंप्लाइज, सॉरी, Q का बताओ क्या बनेगा. ट्रू फॉल्स ट्रू ट्रू. व्हाट इज द नेगेशन ऑफ दिस. नेगेशन क्या होगा इसका. P इंप्लाइज Q का फॉल्स ट्रू फॉल्स फॉल्स. ये वाला किसके, ये वाला जो ट्रुथ टेबल होगा इट इज इक्विवेलेंट टू विच ट्रुथ टेबल. टेल मी. FTFF. थिंक अबाउट इट. थोड़ा सोचो, ठीक है. आपके पास ऑप्शंस होंगे बट स्टिल थिंक अबाउट इट कि दिस ट्रुथ टेबल FTFF इज इक्विवेलेंट टू विच ट्रुथ टेबल. यू कैन यूज एंड, और एंड, इफ एंड ओनली इफ. तीन ही बताए बस मैंने आपको, तो उससे उसमें देखो, ठीक है, नेगेशन किसका इट विल मेक द ट्रुथ टेबल, जिसमें ये वाला आ जाए FTFF. थिंक. अच्छा, शैल आई गिव यू द ऑप्शंस. ऑप्शन दूं, ठीक है. ऑप्शन किस तरीके से आएंगे, चलो लेट्स सी. जैसे फॉर एग्जांपल ऑप्शन आ गया, आई बिकम ए टीचर, ठीक है, और आई विल नॉट ओपन द स्कूल. इसका क्या मतलब हुआ. P और Q आ रहा है समझ में, ठीक है. मतलब आई विल बिकम ए टीचर और आई विल नॉट ओपन स्कूल, इसका मतलब, सॉरी, P एंड नेगेशन ऑफ Q. अंडरस्टूड. चलो, आई विल बिकम ए टीचर एंड आई विल नॉट ओपन द स्कूल. आ रहा है समझ में. ये देखो इधर, आई विल नॉट ओपन द स्कूल. तो इस तरीके के ऑप्शंस मिलेंगे आपको, ठीक है. तो कैन यू टेल मी इन दोनों में से कौन सा आंसर ठीक है. चलो लेट्स चेक. P, अच्छा पहले बताओ नेगेशन ऑफ Q क्या होगा, बिकॉज ऑब्वियसली आई विल नॉट ओपन स्कूल इज नेगेशन ऑफ Q. व्हाट इज नेगेशन ऑफ Q. FT. व्हाट इज P और नेगेशन ऑफ Q. P और नेगेशन ऑफ Q, इन दोनों के बीच में बताओ. ट्रू फॉल्स का और आ रहा है बीच में. ट्रू 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 का ट्रू, फॉल्स फॉल्स का फॉल्स, और फॉल्स ट्रू का ट्रू. क्या ये इसके बराबर है जो हमें चाहिए. ये दोनों इक्विवेलेंट तो नहीं है. लेट्स फाइंड आउट P एंड नेगेशन ऑफ Q. P एंड नेगेशन ऑफ Q, इन दोनों में एंड चाहिए मुझे. सो T एंड F का कितना. F, T और T का ट्रू, F और F का, और F और T का फॉल्स. क्या ये दोनों बराबर हैं. आर दे इक्विवेलेंट. ये दोनों इक्विवेलेंट है. सो आंसर इज बी. समझ में आया कैसे करना है. सो दिस टाइप ऑफ ऑप्शन विल बी गिवन इन द पेपर. आई विल बिकम ए टीचर एंड आई विल नॉट ओपन द स्कूल. इसका मतलब P एंड negation of Q is equivalent to negation of P implies Q. ठीक है. So the question will come either in terms of this truth table or either in terms of this statement. ठीक है. So if and then means P implies Q, negation का मतलब ये हो गया, and in the options you will match, you will make the truth table of all the 4 options and match कि कौन सा किसके इक्विवेलेंट है. ठीक है ना. मतलब ऐसे ढूंढना तो इट्स वेरी डिफिकल्ट ऑब्वियसली, है ना, कि कौन सा आएगा, बट स्टिल ऑप्शंस होंगे, यू विल हैव ऑप्शंस, सो यू कैन वर्क आउट ऑन दैट. नेक्स्ट. So another question of matrices and determinants, the mixed question. Let P and Q be two 3 by 3 matrices with P is not equal to Q. Both the matrices are not equal matrices. If P cube is equal to Q cube and P square Q is equal to Q square P, find the determinant of P square plus Q square. ठीक है. P and Q are two 3 by 3 matrices, जिसमें P and Q are not equal, they are not equal matrices, and there are two given conditions. If the cube P cube and Q cube, the cubes are same, and P square Q is equal to Q square P, find the determinant of P square plus Q square. The hint is कि you can subtract the two equations, LHS LHS and RHS RHS, है ना. P cube, subtract P square Q from P cube and Q square P from Q cube, है ना. देखो जैसे if P cube is equal to Q cube and P square Q is equal to what? Q square P. So just subtract these two equations. क्या मिलेगा? P square common, you will get P minus Q, और यहाँ पे Q square common, you will get Q or minus Q square, you will get P minus Q. This is actually equal to P square plus Q square into P minus Q is equal to 0. Obviously P is not equal to Q, that's why P square plus Q square, the sum of the two matrices is equal to null matrix. So if P square plus Q square is a null matrix, that means the determinant is 0. Clear हुआ? If you subtract these two equations, you will get P minus Q common, and P minus Q is not equal to 0. That's why P square plus Q square must be equal to 0. That means null matrix. So the determinant is equal to 0. ठीक है ना? Next. Another question of the matrix. If A is equal to 1 2 3 0 1 2 0 0 1, and if AU1 is equal to 1 0 0 and AU2 is equal to 0 1 0, find the value of U1 plus U2. It's a matrix obviously, है ना? The product of two matrices, A तो दे ही रखा है. If U1 is another matrix, and the answer is 1 0 0. अच्छा, can you tell me the order of U1? U1 का order और U2 का order कितना होगा? Because A is 3 by 3 और final matrix is कितना? 3 into 1. So U1 कितना होगा? So there is a matrix A and U1 is some matrix which is equal to this, and AU2 is given. You have to find the matrix U1 plus U2. ऑर्डर क्या होगा U1 का? U1 ऑफ ऑर्डर इज 3 into 1. ठीक है ना? This equation is same like AX is equal to B, the system, the set of equations, है ना? बिल्कुल वैसे ही है. A is a 3 by 3 matrix, U1 is a column matrix, and the final answer is also a column matrix. So आपको U1 बताना है, U2 बताना है, you have to add these two. You can take U1 is X, Y, Z. देखो इधर. See, A आपको दिया हुआ है. A is this 1 2 3 0 1 2 0 0 1 और U1 आप ले लो X Y Z. इट्स वेरी सिंपल, कैलकुलेशन बहुत इजी है. 1 0 0. बताओ पहली इक्वेशन क्या बनेगी? X is equal to 1. It's very simple. X is equal to 1. Then 2x plus y is equal to 0. That means y is equal to minus 2. So X is equal to 1. And what about Z? 3x plus y plus 2y plus z is equal to 0. So answer is 3 minus 4 plus z is equal to 0. Z is equal to 1. Z तो 1 ही आ गया. So U1 is this. U1 is 1 minus 2 1. Now let's solve for AU2. बताओ AU2 क्या आएगा? 1 2 3 0 1 2 0 0 1 and this is PQR and this is equal to कितना? 0 1 0. So बताओ P is what? 0. Now 2p plus q is equal to 1. So q is equal to 1. So p 0 आ गया, q 1 आ गया. And finally 3p plus 2q plus r is equal to 0. This is 0. So r is equal to minus 2. So finally u2 जो आ गया आपका वो आया 0 1 and minus 2. So what is the final u1 plus u2? So u1 plus u2 is 1 minus 1 and minus 1. ठीक है. सो आप फटाफट ऑर्डर से देख सकते हो बिकॉज दिस इज 3 by 3 ऑर्डर. सो दिस इज 3 into 1 ऑर्डर. सो फॉर द मल्टीप्लिकेशन टू बी हैपन, सो दिस विल हैज टू बी 3 into 1 बिकॉज इसका ऑर्डर 3, ये 3 3 सेम है दोनों एंड द फाइनल ऑर्डर इज 3 into 1. ठीक है ना? सो जस्ट टेक एनी मैट्रिक्स x y z. द कैलकुलेशन इज वेरी इजी. सो यू कैन इजीली फाइंड आउट बोथ u1 and u2 and the addition of u1 and u2. ठीक है. ठीक है, चलो, that's it. Thank you so much. आपको और चाहिए क्वेश्चन तो ले लेना. ठीक है. इसके हैं उसके क्या कहते हैं मैथमेटिकल रीजनिंग के क्वेश्चंस और भी. हो गया. इसे तो ले लो अपना सामान.